Hello, everyone. I hope everyone is doing fine. We have with us Samir. Hello, Samir.
Hello, hi, how are you guys? Can you hear
Samir
me
is
okay?
going to take the stage and introduce himself as well as will tell us about his session. Azure AI Connect Day 3. Thank you, Samir, for being here. I will catch up with you at the end of the session. You're driving, my friend. Thank you so much. You can share your screen. I will see it and I will share it live.
Sure. um, Share screen. All right. Do you see that?
Yes, you're good to go, my friend.
Cool. Thank you so much. Well, thank you everyone for joining me today. I guess we'll start. I'll start with just introducing myself real quick. My name is Samir Mesegar, and I work as a DevRel engineer at SquaredUp, which is a dashboarding company based in the UK. And I am also a two times Microsoft MVP. Um, First being in the Azure hybrid category, and the second one being in Azure AI services. I also organize a community conference called Experts Live India, which is all about Microsoft technologies. You might have heard of Experts Live as a big brand, as a global brand. So I'm the founder and organizer of that in India as well. So today I'm here to talk about monitoring your Copilot, right? So maybe over the course of sessions in this conference in Azure AI, in AI Connect, or in I think virtually any conference that you've been attending in recent times, you may have heard a million times how to create Copilots, right? So you may have heard how to create one using maybe the pro code way or the no code way, low code way, right? Using Copilot Studio or maybe Azure AI Foundry, right? So there are a few different ways to create these copilots, and you probably heard which one is the best depending on your scenario. But what I have noticed is we talk a lot about creating new copilots, but we don't talk enough about how to monitor them. And me personally, I coming from a monitoring background, so I've been working as a monitoring admin in the SCOM world. Right, so 6 7 years ago, I was heavily involved in SCOM, System Center Operations Manager. Then I was doing a little bit in Azure Monitor as well. So any system that I see, my first thought, my first instinct, I guess, is to, okay, this is great, but how do we monitor this, right? How do we get the insights out of this system and out of the usage of this system? So that is what I'm going to talk about today. So hopefully you'll be able to find something useful out of this. So why even bother? Why do we even want to? Is it not enough to create awesome agents? Sure, it is. It is the first step, but the job does not end there, right? So the natural progression to creating your agents is to actually monitor them. I want to start with a few statistics, so I can give you an idea as to why we are even here. Now, you may have heard that there is heavy investment in AI. You're probably doing some investment yourself, or your company is doing investment in AI, and you are driving the AI systems. But staggeringly, despite the heavy investment in AI, only 48% of the enterprises are actively monitoring their chatbot analytics. Right, so everybody wants a chatbot nowadays, right? And it is very natural to have that instinct. AI gives us a lot of convenience, for sure, right? So for summarizing text, for getting answers in natural query language, perfect, right? It's very easy, very intuitive. But then again, we have to also make sure that the users are having the best optimal experience out of these chatbots, right? AI is well known for hallucinating, right? Still, we see quite a lot of hallucination, and it is important that we capture that, and it is important that the users do not get demotivated to from using the chatbots, just because you are not monitoring their experience, right? So quite surprisingly, only 48% of the enterprises are actually monitoring their analytics. Now, while 91% of organizations plan to increase investment, only 13% of successful projects report seeing a return or positive ROI within the first 12 months. Right? Again, very interesting. Everybody wants to invest in the AI. Everybody wants to create chatbots. In fact, 91% of the organizations, like virtually all of them, are planning to increase AI investment, which is a good news, right? If you're using it wisely, definitely it's a good news. But only 13% of the successful projects are actually in the positive ROI within the first 12 months. And I don't know about you, but I think this has a lot to do with the first statistics, the statistics above that we talked about, right? Because you are not monitoring your analytics, you don't know what the user experience is with the chatbots, and users are just quietly, abandoning your chatbots, you're abandoning your AI systems. So again, only goes out to show why, if you want to be in the 13% of the successful projects, please, let's monitor the chatbots. Now, 72% of enterprise users say that they will stop using corporate AI assistant entirely after just one or two noticeably incorrect or unhelpful answers. Right? Again, a staggering number, 72% is a lot. If 72% of your users are having a bad experience, then I think the problem is not with the users, the problem is with the system, right? So the problem is with the AI assistant. So again, this is just a human tendency, right? If you know that there is a place to ask questions and you ask questions, and but you get wrong answers, then you're probably not going to ask the same source again, right? You're probably going to go to a different source, or you're probably going to manually find out your answer yourself. So again, a significant number of enterprise users are very volatile, let's say, because I think the challenge with copilots today is not creating one, right? Because there are different ways to creating it, but it is to actually provide a reliable and robust experience to the users so that they keep coming back to use your chatbot, so that your adoption of your AI system is high. Right. So hopefully that gives you some context as to this is a real problem, right? So this is not something that we are trying to make up. This is industry data, and based on this data, we are clear that we need to act. Now, there are some challenges of monitoring copilots, right? So when I say copilot, I'm talking about chatbots. Hopefully, I made that clear. Right. So there are autonomous agents as well, right? So you don't have to. They will be triggered autonomously by some set criteria, and they will perform their actions and whatnot. But this discussion today, this conversation is more focused on a chatbot, like an interactive chatbot. You ask questions, it gives you back answers, right? Things like that. So what are some of the challenges, right? So there is no deterministic input or output to a chatbot, right? So you cannot control what kind of questions the user is going to ask, or you cannot control the wording of the questions, right? So same questions might be asked. Some people will ask it in different words. Some people will use different grammar. Some people will probably misspell some words or use some ambiguous language. Again, that is the challenge with using the natural language. So there is nothing deterministic about inputs as well as outputs, right? So even LLM is not going to give you, unless you like very specifically tighten the parameters of the LLM in the back, which I don't think you can do in Copilot, in Copilot Studio. But if you've done that, uh, the LLMs are going to give you like a variety of different versions of the same answer, let's say, right? Even the LLM is not going to give you a fixed output. So that is one of the challenges, right? Then we will compare the experience of monitoring Copilot chatbots today versus monitoring like more traditional applications down the line. But this is basically a traditional application will expect a fixed input and will deliver an a fixed output, which is not the case here. There's also no clear definition of success, right? So what a successful answer means in Copilot is not fixed, right? Because you may ask it a question and it may give you an answer quite confidently. But again, we know that this answer may not always be helpful, or it may just be partially helpful. It may give you a partial answer. If you've asked it 4 questions, maybe it has given 3 answers correctly, but on the fourth question, it has hallucinated strongly. So how do you say, is this a success? Is this a failure? Right. So there is no clear definition of success. The failures here are conversational. They are not technical. I say not technical, but sometimes they are technical if the Copilot itself is not answering the questions for some reason. But other than that, it is mostly conversational, right? So if you ask a question, Copilot will give you an answer. It is not going to say that error 400 whatever, or 4xx whatever the code may be, but it is going to give you an answer, right? Regardless of whether it knows whether the answer is right or wrong, it is going to provide you an answer. So it is going to be a conversational. So the user will say, no, this is not what I asked for. Please try again. Then it will probably give a different answer. But again, that might also constitute as a failure if it is another hallucinated answer. Right? So this failures are conversational. The users adopt before systems do. Basically, what I mean by that is, if I so this ties back to, I guess, to the previous one of the statistics that we saw. Is like, if I ask Copilot a specific question, but I'm not getting the right answer or the answer that I expect, I am probably just going to tune out, right? So I'm going to, say, screw this. I'll just go and find my answer myself. So system is, if it does not obey you one time, it is, as a user, even if you keep asking it the same question again and again, the system is not going to adapt, because it is set on certain, maybe it is based on some knowledge in the back, or it is, calling some specific set of tools, topics, things like that in the back, right? So systems, you are not going to adapt that much, but the users might just tune out, they might just leave. And that is what the silence is the most common failure mode, right? So even if you ask a question, Copilot replies, but if it is not the right answer, as far as Copilot is concerned, it has answered a question, it has generated some output, so it is not going to see that as failure. But as a user, we know that, no, this answer is completely nonsense, this is not what I asked for. So I might, as a user, just get frustrated and maybe just click on the close button, or I might just click somewhere out. I might just minimize the window and do try find the answer myself. So I'm not explicitly going to, there is no guarantee that as a user I will say to the Copilot, no, this is not what I asked for. I might just frustratingly just tune out. So this is comes back to this concept, is that Copilots don't fail like traditional apps do. Let's take a quick look at how. So in traditional apps, we have exceptions, we have crashes. Like, so we are used to that. If an application that I'm trying to access, if it freezes, or if it gives me some exception saying that cannot load, or gives me an error code like 40150, whatever, 4xx, 5xx, whatever errors, but it crashes, so I know that is a failure point. So it has crashed, I cannot access it, clear failure. But Copilot, on the other hand, even if you ask it a question that it does not know an answer to, it is going to hallucinate, right? So it is going to give you politely but confident answers, right? So it is going to say, no, this is what, and I have experienced this firsthand, right? So I was working with an agent that was grounded in Confluence Space. That Confluence Space basically had the information, or the trail of how we have responded, or how we are um, in contact with our different customers and potential leads and stuff like that. So when I was asking it a question about customer, hey, can you tell me what was the last meeting that happened with customer XX, right? But Copilot would give me a very enthusiastic answer, a very confident answer. Okay, so this is your history with customer Y. Like, that is not what I asked for. I asked for X. You're giving me information about Y. Why are you doing that, right? So I will go back, say, no, this is not what I asked for. I asked for X. But then again it will say, oh, I see my mistake now, so here is the information about X, while giving me information about customer Z, right? So this I've firsthand experienced. So it is going to be polite, it's going to be confident, but it is still going to give you wrong answers, right? So as far as Copilot is concerned, it has given you an output, so that is a success in its dictionary. But for us, no, it is not. And so in traditional apps, retries, if your application is trying to reload, then it is resilience, right? So we want to distribute our application, we want to distribute the users, and if the user cannot hit one URL, maybe after a period of time we are going to reload, or we are going to retry, or we are going to redirect them to a different URL. And so that is really resilience that you are building in your traditional application. But if a user is retrying, asking the same question again and again and again to the Copilot, then the user is just confused, or the user is just frustrated, right? So if the customer is not customer, but a user is trying to ask a question again and again and again, it's not resiliency, it's frustration, right? And that is what we find with monitoring. In monitoring of traditional apps, we do it to find bugs, we do it to find bottlenecks, right? We do it to find exceptions and crashes and things like that. But in Copilot, this is in addition to what finding the bugs, of course, right? So in addition to the traditional apps, we are also monitoring the Copilot to find the user frustration, or we're trying to find the user experience, let's say, right? Experience with the Copilot. Now, in traditional apps, logs are pretty straightforward, right? It will give you, okay, this process started, this step executed, or this service was called, this process took milliseconds of time, or this particular exception was reported, things like that. Pretty straightforward, simple. We are used to seeing those logs. But in Copilot, logs require interpretation, and I will show you an example of what actually that means. But yes, it logs some things. It does not log everything, but it logs some things. Even those things you have to interpret, right? You have to see a couple of 3, 4, 5 log entries in succession, like as a group, to identify what went wrong. So that is what, in my personal opinion, you cannot just simply dashboard on whatever telemetry that you get. Of course, there are some out of the box dashboards, etc., that I will show you in a bit. But there's also some interpretation that you have to do on your end. For traditional apps, health more or less equals correctness, right? So if the application is healthy, which basically means that I can log into it, I can perform my actions. It is generating input outputs for me. If it is creating entries, maybe it is logging something in the database, and things like that. So more or less, the health of the application is the functionality or the correctness of the app. While on the Copilot, it is not always the case, right? We have talked about hallucination. So even if the Copilot is healthy and is very eager to help you, it is always on, right? So you can ask it any question anytime, but it doesn't necessarily mean that it is going to give you useful information back. Again, in traditional apps, failures are technical, while failures are experiential in Copilots. And experience is everything, at least for now, in the early days of Copilot adoption. So if you you are involved in some Copilot projects, or if you are building some Copilot agents to for your customers, then in everybody, I think everybody knows that AI is not perfect. Agents are not going to give you a perfect answer every time. But as the maker of the agent, I think it's your job to make sure that you can give them the best experience possible, at least in the early days. So when the users get more used to it, maybe, or when the agent is finds more acceptance in your user base, then great. But all of that hinges on what the initial experience of the users was with your copilots or with your agents. And so failures are experiential in copilots, and we want to minimize those failures. Now, how do we monitor copilots? There is actually a fair bit of telemetry that comes out of the box from these agents. So there are two ways where you can find this telemetry. One is the Copilot Studio Analytics, which is baked into the actual agent creation wizard itself in the Copilot Studio. But you can also go in like settings and advanced settings. You can configure your own application insights instance as well, where you want to send your telemetry to an App Insights workspace. The Copilot Studio Analytics, the data is stored in Dataverse, while in Azure, in Application Insights, it goes in an Azure Monitor workspace. Now, these analytics are different, right? So they are not the same. It's not like the same data is being logged into two different places. No, the data in Copilot Studio is more high level. It is more on the session, at the session level. So the user logged in, sent 5 questions or maybe 5 messages, and the Copilot called some topics, and this was thumbs up or thumbs down. And so this is at the session level, at the highest level. You are getting this telemetry at Copilot Studio Analytics. I will show you in a bit, of course. But then in Application Insights, you are going much deeper, right? So you are going into the individual step. You are going into the actual user journey. You can also log the actual prompts that the user is sending, and the responses that the LLM is getting back, right? So in that case, you can actually go much deeper than just at the session level. You can go like individual message level, individual topic calling level. You can investigate at that. Now, obviously there is not much customization available in Copilot Studio, but in App Insights, you have the full control as to what you want to log and what you want to do with the entries that you have logged. Right? We will take a look at how that looks like in a bit. Yeah, this is basically what I was saying. This is just the different kinds of telemetry that is being logged into these two different platforms, the Copilot Studio Analytics pane and then the App Insights workspace. Instead of reading these out, I think I've already called out most of them, so I will just show you how that looks like. Before we go into the demo, I just want to quickly talk a little bit about, I mentioned earlier that the logs for copilots require interpretation. And so what is that interpretation that I was talking about? So how do we infer the user behavior out of these log entries? Now, if a user is asking a similar query, like semantically similar query, maybe in different words, but semantically similar query repeatedly, then it probably means that the user is not getting the answer that they want the first time or the second time or the third time. right? So if they are asking it repeatedly, but basically what it means is Copilot is not helping, user is adopting. Like the user is trying to compensate. Maybe it understands this language. Maybe if I, ask it more nicely, probably it will give me an answer. Maybe if I use different grammar, it will give me an answer, right? But despite that, user is getting frustrated. The Copilot is not helping. If your logs indicate there is rapid topic switching, right? Hopefully you're familiar with what topics are, but if not, I'll quickly show you on how that looks like in the portal. But if the topics are switching rapidly, what that means is the intent recognition or routing of that recognition is broken. Basically, what user is asking, Copilot is not able to decipher or understand what the user wants to do. Right? So it is trying one topic. Oh, maybe this is what user wants. Oh no, let's try different something else. Then it hops on to a different topic. Oh no, this is also not what the user wants, right? So if you if the topic is switching rapidly, then it is probably an indication of that the routing or the intent recognition itself is not working well. And topic starts with no action. This is basically again the follow-up of rapid topic switching, right? So there are there is a design, but it does not provide any value, right? So you've created maybe 5 different topics, thinking of different scenarios, different ways a conversation could go. But the topic is being entered, so the agent enters that or invokes that topic, but it does not provide any output. It does not take any actions, right? So you may have configured some actions as to, okay, call this tool. If this topic is call this tool, if it is applicable, but no actions are being performed at all. The agent is not giving anything back to the user. So you made the design, you've thought things through, but something is not working there. Short conversations might engage or might you know indicate silent abandonment, right? So if a user, so again going back to the first slide, users would say like, okay, one or twice I will ask my question, but if even 2 times asking, it is not going to give me an answer, I'm just gonna go, right? So if it's a short conversation, it probably means that it could mean that the user got the answer the first time, but it could also mean that it is the user has abandoned, right? So, and this is where the challenge is, right? This is where it becomes tricky. How do we interpret this? So you have to actually scan the entries above and the entries below to work out what happened in this conversation. Was it successful? Was it not? Right. So that is where the interpretation comes. Channel specific retries. So if you published your Copilot in different channels, one in Teams, one in Slack, maybe one in your website, user are interacting at different places, but you are noticing that from one channel there is a particularly high number of failures, right? So let's say Teams bot works, but the Slack bot does not work. So that may not be a problem with the agent itself. It may be something in the channel mechanics is broken. So no errors, high activity, right? Which basically means that it is healthy but useless. These are long conversations as opposed to short conversations, right? So if a user is particularly persistent, let's say, it is going to say, okay, I have this chatbot, I'm going to ask it the same question again and again and again. It is healthy, it is giving me back results, but these results are useless, right? So again, you have to look out for this pattern, is that, okay, there are no errors, but successively quickly in a short period of time, there is high activity, which probably means that the user is repeatedly asking the questions again and again. Right, so with that, I will show you a quick demo. Let me switch my screen. Where is my, this one? Yeah. Okay. Hopefully you see the Azure portal. So let me actually start with the Copilot Studio. Just open it here. Let's start with Copilot Studio. So I will show you a little bit of how my agent is configured. Then I will jump back briefly in the Azure portal, show you how that actually looks there. And we will also take a look at the chatbot itself and how that works. So this is my agent. This is the Zendesk ticket assistant. So this is basically configured to answer any questions that I have about the tickets that were raised in our Zendesk and in Zendesk organization. So you would see that here, if you're not familiar with Copilot Studio, um, this is where you configure the agent. So this is the analytics, but we have a longer version of that here, which I will show you in a bit. But this is basically where you configure the knowledge. Where do you want your agent to, grounded in what knowledge? Then the tools. What tools do you want it to call? So get items. So this is basically an action that it performs to retrieve the Zendesk items, and then it posts a message in a specific Teams channel. It's pretty simple, very straightforward. As you can see, I've got some instructions describing what I wanted to do. This is the knowledge that I showed you, right? So this is grounded in a couple of websites that we have here and stuff like that. Again, I don't want to go talk about how to create an agent. Again, I think you already know, or you will hear probably other more qualified speakers to tell you how that works. But I will switch over to the analytics tab here. What this shows me is the summary of usage for this agent in the past whatever time, right? So I can select the time range. This is the AI generated summary. This will appear only when you are using your agent long enough, right? So if you create an agent and don't see the summary immediately, then don't worry, it will appear. It has to have enough telemetry to interpret, basically. This is the overview. As you can see, I've been using it for a while now. So I've got some, let me switch to maybe 30 days, maybe we'll get more data. Yeah, there you go. So this is the overview, how many conversation sessions that I've had in the last 30 days now. What was the engagement, total reactions? So reactions are basically when these things here on the right? So was it thumbs up or thumbs down, like or dislike? Average DAU runs, how many you can. So a run starts when a trigger happens, right? So a total includes successful and failed runs. So every time an agent is called or a trigger is triggered, a run will happen. 91% of those runs were successful, according to Copilot, according to these chats. But I can tell you by my experience, yeah, it may have successfully ran, but it did not always produce correct output. Right? And this is the challenge that we were talking about. And I will show you how that looks like in a bit also. Average duration of response was 335 seconds. I think this also runs that take a long time might need more specific instructions. And so this is also giving you what these metric actually mean and how you can potentially improve this metric. Copilot credits used. So Copilot licensing works on credits now, right? So you can buy some credits beforehand, and each action, each tool call, each topic, each trigger will cost you some credits. I don't want to talk about credits in too much detail here, but if you just look up at Copilot agent licensing, maybe will give you for each action how many tokens are used or how many credits are used rather. And then you can configure settings. So you can actually, these are your custom values that you can like. This is an approximation, obviously. Right? So this is not going to give you a perfect answer, but it will give you approximately per run. I would do the same thing in 5 minutes, but the agent is able to do it in, I don't know, a single run, which might take 5 seconds maybe. Right. So I'm saving effectively 5 minutes. I'm saving 20 pounds, dollars, whatever. Right. So you're saving a particular amount. Approximation is this is not the exact figure. Effectiveness, so the some of the other things like how many conversations were resolved, how many were escalated. So nothing for me here, because again this agent is not very sophisticated, so I haven't been escalating it a lot to a different level. But you can see that if I did, then this escalation bars will also go up and down. Abandoned, you'll probably see, right? So I've got a few abandoned sessions, right? So here I've got 3 sessions that I abandoned, right? So I engaged in 3 sessions and I abandoned all 3 of them. Now this is at a higher level. This is giving me a number. It is telling me 3 sessions were abandoned, but it does not tell me anything about the why. Why did the user abandon this session? Was the user unhappy, or was the user did the user get their answer and just happily clicked away? Right. So we get no insight into any of that. Unengaged, this is basically for a period of time. If you are not engaging with the session, then I will give a log an event like that. With successful runs, again, right? So you will see most of these runs were successful. A couple of them were failed. 5 runs failed here on Friday. But again, these are just numbers. It does not tell you anything about the actual user experience. Then there are some other metrics like tool use, like how many times a particular tool was called. So get items was called the most. And then posting in a channel was never called, because that is something that I recently added and I haven't tested it much. But if you've got a working agent, you will see a number of tool calls that the agent is performing. And then some satisfaction levels here. So reactions is to basically user reacts to agent's messages. You will see the reaction count here. These things again, like I told you about. User satisfaction for sessions after user submits survey responses. So when a conversation or a session is complete, a survey will show up, right? So how something like, how happy are you with the outcome of this session or this conversation? Then you would say on a scale of 1 to 10, yeah, I am 5 points happy, or I'm 6 points happy, things like that. So if you do that enough, you will get those insights here as well. Now quickly going on to, oh, hang on, I'll just show you one more thing. If you go to settings, and advanced settings, here you can actually paste your connection string to the application insight resource that you have created in Azure portal, right? Once you've pasted that here, it will start sending the telemetry to that Azure Monitor workspace. And now let's go back in the Azure portal and see what that actually looks like. So this is my workspace, the Index Assistant agent. This is where I'm sending all my telemetry. Obviously, it will start from the overview. It will have some telemetry here, but in my experience, it almost never works. But you have other things to see these metrics. So you can actually investigate, or you can go into monitoring, and then look at metrics from here, logs from here, or workbooks that you may already have, which we already have one here, which is Copilot Studio dashboards. So I find this quite decently useful, because again, this is where, let me see if I can fix that. Let's tone it down a little bit. Okay, interesting. The demo gods obviously are don't love me today, but literally before this session, when I was checking this out, this was working. Okay, so for some reason it's not working now, but it will give you some metrics as to what users are coming back to your agent, what was the single turn versus multi-turn conversations, daily conversation volume, what the performance of the agent was calling the tools and getting you the output, total response time from the time that you asked a question and an answer came back, the success rate, how many times the tool was successfully called, and so on. Now, if this loads, that would be really helpful. It was working just now, literally, like before the session. Oh, maybe. Something's loading. Oh, there you go. Okay. So this is these are KQL queries, as you can see. It is running the queries in the back, and it is giving us an output in this dashboard here. And so this is a great starting point. But again, this is all built on the default telemetry, whatever that the agent emits by itself by default. But this is not always useful. Again, this is giving us a lot of numbers. It is telling us that this many sessions were abandoned, this many tool calls were made, this was the response time, and these were the topics that were executed along with their execution time. But it does not give us at individual level what the experience of the user has been working with or talking with this agent. So how do we find that out? So obviously, now very conveniently, actually, we can, in the topics, we can add in our own custom telemetry. And I will switch over to my agent again in the Copilot Studio, and I will show you one quick example that I have. Now, again, this is not the most sophisticated example. This is just for illustration, just for the demonstration. But hopefully you will get the idea. I'm currently limited with my resources, so I couldn't produce anything sophisticated. But what I've done is I noticed to one way to control or to identify user abandonment was to basically ask the user, right? If a user has asked a question to Copilot, Copilot has answered, but the user does not say, hey, okay, thank you, that answers my question, or no, that this is not the answer that I was looking for, which would be a clear indication for the agent maybe to try again. But I've received an answer, but I have just left the screen without giving any feedback. Then how do I know as an admin or as the agent owner how my agent is performing? So in a case like that, you could do something like this. Again, I'm not saying that you do exactly this, but I thought this was a quick and dirty fix, which is if this topic is a custom one. So I have created this one. And if the trigger is that the user is inactive for a while, so after asking a question, let's ask it a question. So actually, how many tickets were raised last week? Now, I don't know if it will answer. It might just fail, but that does not stop us from demonstrating. Yeah. This gives you an example of what the soft failure, as I like to call it, is, right? So this is it is giving us an answer. It is producing something and looks useful, so to say, but this is not the answer that I was looking for. I was asking for the number of tickets, and this is not the number of tickets. This is telling me how to get it, but not, it hasn't done it by itself, which it was supposed to do. No, I've been tinkering around with this agent quite a lot, so I must have messed up some configuration somewhere. But no issues. That is not to say that the demonstration does not work. So I've received this information, and what I'm doing now is I'm just, you know, suppose let's imagine that this was an actual bot that I was interacting with, and I asked it a question, got a response back. I did not leave any thumbs up or thumbs down. I did not say thank you, that answers my question, or that I said nothing. I just simply left. I went back, trying to do something else. I'm just going to close this up. Actually, let me ask it to. So I published this agent in Teams as well. So we'll ask it the same question in Teams. Maybe we'll demonstrate there how many tickets were raised. I will show my screen in a bit. What I did. Right. So what I'm doing now is I'm enacting a user abandonment session. So I've asked my bot a question, the bot has answered, but I'm not going to give it any feedback. So let's let it sit for a while, and we will go back to our agent, to our Azure Analytics. We'll go to logs, and I will show you the recent logs in the last 24 hours is fine. Just gonna run this. Right. See, so these are the logs that have been logged by the agent. So a lot of these are system. I have not configured this. So these are the ones that are configured by default. You will see things like bot message send, when a bot sends a message, when a topic action took place, when a topic started, when a topic ended, when a message was received to the bot. And yeah, I think these are mostly that. Topic actions, bot received, bot sent messages, and things like that. Again, it is logged, but not very helpful. What I'm trying to find is, a while back I asked it a question. Which one am I looking for here? Okay, so what I did earlier was I sent some messages to my, here you go. You know what, let me, one last time, let me quickly switch my screen. I'll probably see what I'm actually doing. Stop share screen. My Zendesk bot. Okay, so this is the bot, right? So I asked it the same question. How many tickets were raised last week? And it has given me an answer. The same answer that we saw in Copilot Studio. Again, not the exact count which I was asking for, but a generic answer. So this is what I called a soft failure. Right? So this is, as far as Copilot is concerned, it has given me an answer, but that answer is not satisfactory. So I will call that as a failure. But there are some instances, so I was trying this out earlier. If you ask it a question, summarize tickets raised yesterday, it might even just simply, simply fail. So this is an actual exception. So these ones are easy. These are easy to find in the logs. So this one happened at around 5:12 p.m. So maybe with that, I can find it in my change the local time, 5:15. Right. So these events are logged, saying that an error occurred, or an error topic um, was logged. Right. So these are easy to find. These are easy to identify. What is tricky are these ones. Right. So what I've done is after, if we give it some time, it is going to. So again, I am enacting. Inactivity from the user. I'm not going to say good, bad. I'm not going to say anything in response to this question. So as an admin, I do not know whether the user that asked the question actually got the answer or not. So if we give it enough time, I think I've configured it for 5 minutes or so, it is going to give me an adaptive card. Basically, it is going to give me a reminder asking, hey, I noticed that you are inactive for 5 minutes or so. Was your last query answered? Right? Was it answered or not? So I'm going to actively prompt the user to actually provide me some feedback on the last query that they asked. So again, it is something, it is not foolproof. It is, user still can ignore the reminder as well, but at least you are giving some kind of encouragement to the user to actually submit some feedback. So yes, I was happy, no, I wasn't, right? Things like that. So it will come. Let's not wait for it in the interest of time. Let me switch over to my PPT again, and we can probably wrap this up. Where is StreamYard? Present screen. Right. So hopefully that demonstration was useful in the way that I know that the agent itself or the custom telemetry that I logged was not the best or the most useful. But what that does basically is that topic is configured if after that pop-up comes after 5 minutes or whatever time that I've set up, it will ask user, were you happy with the response, yes or no? If yes, then it is going to log a custom event saying that yes, the user was happy. If not, it is going to if it's going to log another event saying that no, the user was not happy with the response. Now these straight up, like straight away direct events are easy for me to find later as well, right? So in the KQL, I can just simply query for all the queries or all the results that have an event with a particular value, say like no, the user was not happy. So I can find those events, and then I can actually investigate as to what exactly went wrong, and then I can iterate on that process. Maybe I can fine tune that topic, maybe I can add some more conditions, maybe adjust the instructions a little bit, maybe change the tool calls, etc., right? So that is a very simple. There you go. So hopefully if you can see that it has asked me for a feedback, whether it was received, if the answer was received was correct or not. So but in more serious cases, I guess, when the where you can use this is an abandoned cart scenario. For example, if you have suppose you're running like a website, a checkout website, right? So if you have a user that is abandoning a lot of sessions, or rather a lot of session, what am I saying? A lot of users are abandoning the sessions, then you can identify why, right? At what step did the user, what was the last step that the user left before they stopped proceeding further, right? So the Copilot agent will only, the custom telemetry will give you, okay, this session was abandoned. So it will just add +1 to the number, but it will not tell you why. So this is a golden chance to actually write your own event. Okay, so step 1 complete, step 2 complete, step 3 complete, but step 4 was never called. So maybe users are, for some reason user dropped off on step 3. Now near misses, intent near misses, right? So semantically same. If your agent is close to deciphering the answer intent but not quite, so it is triggering topics but it is triggering the wrong one. So in that case also you can add a custom prompt, maybe saying that okay, that is not what this is what I was looking for, or this is not what I was looking for. So when you click on it, it will a custom event will log. And then for compliance and audit trails, of course, so if you are working with a legal bot, let's say a bot that is based on some legal information, legal documents in the back, and you want to make sure that users are checking a box, an equivalent of checking a box rather, which is that they accept or refuse certain terms and conditions, or that you want to make sure a disclaimer is always showed for legal reasons again. So you can add that custom telemetry. So this is not something you're going to get out of the box. You have to add a custom telemetry event for that. Cool. So these are just some of the examples, but the limit is the sky. You can basically ask or log any events that are more relevant to you and that work your that fit your use case the best. And again, thank you for joining me. Hopefully that was useful. So if you have any questions, please feel free to send it my way if you have my LinkedIn, etc. And I will probably share this deck with you via the organizer. So hopefully that helps. Thank you.
Thank you, Samir. I found the presentation quite useful personally. Today, it happened today that I had a discussion with a colleague of mine about the Copilot Studio, and I will propose this recording for him to see, because we were having this specific discussion about monitoring. I really liked your approach. So thank you so much for enlightening us about Copilot Studio. One question though, maybe it's not the time to answer it, but just if you know, I know that were some changes regarding the licensing. Is it true that we can get like how is it reserved instances in Azure? We can prepay for some credits for
Yes,
our
yeah,
copilots,
absolutely.
right?
Yes.
Yeah. So,
Yeah, you can
okay.
pre-purchase. I think with like if you there's a package of I think 2,000 credits or something. You can
Yeah.
prepay, and based on whatever your usage is, how complicated, complex your agent is, it is going to consume certain credits.
Yes.
But having said that, even if you cross those credits, you can still you can pay as you go. So even
Yeah.
if you don't
Okay.
have anything, if you're not sure, you don't want to commit to 2,000 credits, maybe you are just experimenting.
Yeah.
Not only 2,000, you can buy
Yeah.
multiple packs of certain credits. So if you're not ready for that commitment, you can just pay as you go. Look at how your user base is accepting, adopting to your co-pilots, and then maybe down the line purchase some credits if when you're free, or rather when you're ready.
Okay. Well, many thanks to Shamir for coming in Azure AI Connect 2026. We saw quite an interesting presentation for day 3, and we have our next speaker in line. Samir, thank you so much. Hopefully, we'll see you in another
Thank you so
2
much,
hours.
Konstantinos, for having
Uh,
me.
Thank you for making us the honor to be here.
Have a great rest of the event. Thank you.
You too, my friend. You too.
Cheers. Bye
Great.
bye.
So we are flowing. Heat is with us. I will just play one video, just one small, very small break, 1.5 minutes, and we will be back with Heat. We have a very interesting presentation about Azure AI Foundry. I will keep you on your toes. So let's see the video, and we will be right back with our next speaker. right. So let's get our next speaker in our stream. Welcome, my friend. Uh, am I pronouncing your name correct? Is it Abhijit or Abhijit? Hello and welcome.
Hey, Konstantinos. Yeah, that's correct. It's Avijit.
Abhijit. Okay, Abhijit. Yeah.
Yep.
So welcome. I know it's a holiday in your place in India, but we are so honored to have you with us, and you're going to explain about Azure AI Foundry, right?
That's correct, Konstantinos. Yeah. It is
Great.
about the AI Foundry, which is renamed now as Microsoft Foundry,
Yes.
right? And also about the pricing model, how it operates, right? Because it is not as easy. So I'll walk the folks through who will be joining. Definitely will benefit from this. Yep.
Perfect. We need this. People are jumping onto AI and then they forget the bill, and then the bill comes, and there are
Yep.
surprises. So thankfully, we have
Makes sense.
Avicii with us to tell us all about it. The stage is yours, my friend.
Sure. Let me share my screen. Meanwhile, please let me know if my screen is visible.
Yes, we can see your presentation.
Yeah, thank you for the confirmation. Well, good afternoon, good evening, everyone, wherever you are. Thank you for the opportunity given to speak here, and I am really thankful for the session I'm going to host today. So my name is Avijit Prasad, and I'm a cloud consultant working at industry solutions delivery at Microsoft. Today I'll walk you through Microsoft Foundry and its infrastructure and how the pricing is actually found, right? So because AI can only be leveraged once we know, or I would say the ROI would be useful when we understand how the cost governance works, right? So that becomes a surprise for the business leader. So I'll walk it through as well. So, yep. Let me dive into directly into the contents that will be covered for today. So, AI is reshaping the globe. So, we'll see how we know AI is a buzzword. It is, every day in day out, AI is being enforced in each and every org, right? So, we'll learn how AI is reshaping the planet. We'll also know what Microsoft Foundry is and what is inside Microsoft Foundry platform upon recent advancements made. Also, I'll walk you through the Foundry portal, and also after that we'll cover some Azure infrastructure which enables this platform as a service, and also we'll learn how to take out the pricing for the Foundry resource, right? And I'll walk through even how we can deploy a Foundry resource to Azure portal. So there'll be a small deployment demo at the end, and then we'll have some resources to get started if you want to take kickstart your journey in Microsoft Foundry. So AI is reshaping our world, and it is not in years, not in months. It is right now. It is happening. It is pre-existent now. AI is no longer a future promise. It's here, right? So it's unlocking creativity, productivity, and innovation at scale. We have never seen that before, right? From natural language to visual understanding, everywhere, right? And also in the advancement in the area of generative AI, right? AI is redefining the enterprise capability from cost center to strategic differentiator, from easy to use Copilot experiences that come out of the box to custom generative AI solutions, or custom Copilot, I should say, right? Which every organization is trying to explore now and take advantage of AI. Uh, so here comes our the subject of the day, which is Microsoft Foundry. But before I start, I would like to say what generative AI is. I'll just start with the basics. Generative AI is a field of AI that creates new content. It can be an image, it can be an audio or text or video, right? I believe many of us have used tools like Copilot or maybe ChatGPT. So these are all generative AI solutions, right? And it is also capable of, with a multimodality. By that I mean it does not understand text, it understands audio, it understands images, and it can understand video as well with the latest advancements made in the field of generative AI. So what has been happening is generative AI has exploded into the enterprise world. Developers were excited, business leaders were curious, innovation teams were experimenting, right? Rapidly, chatbots were built on public APIs, and even during the experimentation, what was seen that if it might not be intentional, but you are pasting the sensitive data in the external tools, right? And the token costs are growing without visibility. Hence, there is no security or cost control and governance in whatever AI experimentation you are doing, right? So, seeing this shift, right, seeing this hurdle, Microsoft created Microsoft Foundry, earlier known as AI Foundry, and that's why you might see as the title as AI Foundry. But after the build event happened last year, November, so it was renamed to Microsoft Foundry. Microsoft didn't create the Foundry to give access to just to the models. It created Foundry to solve all the AI chaos, right? So it is because uh, because this tool will serve as a cost visibility, it will serve as governance, it will include responsible AI enforcement and also identity integration, and it's just not the models, right? So Microsoft Foundry is a one-stop unified solution here. So this is what it looks like inside the Microsoft Foundry. The models, the agent service, IQ, tools, machine learning, control plane, and it is stretched across from cloud to edge or on-prem. And underneath there is security, compliance, and governance, right? So at the top of the core building blocks models, I would just give a high level overview that if you want access to the models, whether it can be reasoning model or coding model or a multimodal AI model, right? You can get that over here in the Microsoft Foundry. It hosts both the Microsoft hosted as well as external party models in one area. So no need to juggle around. Then there's agent service. So we have been hearing a lot about agentic AI, right? So if you want to advance in this sector, definitely agent service is where you can build and orchestrate intelligent AI agents. And then comes the IQ, which enables reasoning, planning, and intelligent decision making for agents. We also have tools, right? It allows AI to connect with APIs, enterprise systems, and data. And machine learning supports model training, fine tuning, and customization. All of this are managed through a central control plane, right, which governs deployment, management, and operations. And the entire platform runs across cloud to edge with built-in security, compliance, and governance, right? So Foundry is where idea becomes into production systems. It is, you can think like Microsoft Foundry as a factory, and when you start working in a factory, you start with raw materials, right? So raw materials can be thought of as models, maybe agents and tools, and IK can be assembly lines. Governance will be the quality checks, or control plane can be one control room, right? That's how you can map it to understand it in a we are kickstarting your journey here. So let's look at Microsoft Foundry in details. So Foundry enables AI development teams to drive business results while enabling organization-wide observability and control. You can accelerate the innovation with a complete integrated interoperable AI platform, and you can drive your business results with action-oriented and context-aware agents, and you can govern the AI lifecycle organization wide observability and controls. So Microsoft Foundry acts like an AI app agent and orchestration tool, right? It is, as I told, it is a factory. It builds, if it brings together everything needed to build, manage, and deploy AI powered application. If you are building for your business use case, right? AI app and agent orchestration. Foundry helps you to coordinate multiple AI agents and workflows to build complex AI systems, right? It developers can choose from Microsoft OpenAI models or an open source models depending on the use case you have. And also knowledge and tools. AI apps connect with enterprise data, APIs, and tools to create intelligent systems using techniques like RAG, right? Retrieval augmentation and generation, right? So next is observability and agent controls. So you can, it provides monitoring, safety, and governance, so AI applications can run securely in enterprise environments. And also fine tuning and customization. Models can be adapted with enterprise data to create domain specific intelligence. You can also do that. And also once built, AI application can be deployed across different environments for real world usage, whether it's local or edge or cloud. It is all upon you where you want to do. So this is the whole circle around Microsoft Foundry. Like if you can see, there are 11,000 plus foundation, open, reasoning, multi-model, and industry specific models, right? There are models directly from Azure OpenAI because of the partnership with OpenAI, and then Azure DeepSeek, Azure Mistral AI, Azure Grok, Azure Black Forest Labs, and Azure Llama. So these are directly from Azure. Also, if you want to leverage the partners or community models like from Coher, NVIDIA, right, and Hugging Face or Databricks, etc. So you can also use those models if that fits in your use case, right? In so this is in total how it becomes a powerhouse, right? How Microsoft Foundry brings the brightest brain into the Microsoft Foundry, right? The brain is nothing but the models, right? uh, I'd also like to touch base upon model router in Foundry models. So this is an important capability added in Microsoft Foundry. uh, Microsoft Foundry has a capability called as model router, which is designed to automatically select an optimal model for specific query or task in real time. So that is, a niche, I would say, a new capability being added, and it will really help in, because you don't have to juggle around APIs worrying about the compatibility of the model. The model router will dynamically select the best model for you, and each request provided the model is deployed in your so this will only work if the models are deployed. You know what are the models there, but for request, if the request is, for example, if I say a simple query might go to a smaller or a faster low cost model, while a complex reasoning task may be routed to a more powerful model. So in that case, this model router will help you distribute the request according to the nature of the task in real time, right? So this approach simplifies how the model selection and help organization achieve better performance. First, second is lower cost. You don't have to use high end models all the time. If it can be done through small embedding models, that is fine, or lower cap models, it can be fine, or SLMs is also fine, but not always LLMs are required, so you can choose that. And higher reliability. So model router has been a great, you know addition to the Microsoft Foundry. Coming to the next, if you see that how router has this routing capability over the video capability, if you see, right, it's routing upon the request, and that's how it links with the backend models to serve the request, because each prompt there is a response from backend models. So that's pretty much on the model router side. Next, I will deep dive into Foundry Agent Service. Uh, so it supports key protocols like Activity Protocol, Agent Protocol, and MCP. Many people who are working in AI field will know what Model Context Protocol is, right? It is kind of a USB-C kind of protocol which plugs in with all the agents and services or tool chain around the world, right? It is a great advancement made there. So developers can build declarative agents which are simple prompt based agents or hosted agents where multiple agents collaborate to complete complex workflows. These agents can access models, memory, and tools, enabling them to reason, remember conversations, and interact with APIs or enterprise systems. Also, once the agents are built, they can be published, and all of this runs on agent first SDK, API, and UI with built-in security, compliance, and governance. Right. So this will be mostly from the developers side, because I'm from infra background. So I'll touch base at least on the provisioning part, how you can provision Foundry from Azure portal, right? Coming to the yeah, so Foundry Agent Survey enables developers to orchestrate AI agents using open and flexible frameworks that we have already discussed. But you can select the best models for your use case, and agents can also connect with enterprise knowledge and external tools, allowing them to take actions and interact with real systems. S- Next is the Foundry IQ. So now let's talk about what Foundry IQ is. Powered by Azure AI Search. If model provides the intelligence, Foundry IQ provides a grounding layer for enterprise AI. It connects your AI application which you are developing for your business use case to the knowledge base, which might be sitting in on-prem, or that data might be in your storage account, right? Or it can be in any external data, regardless, right? So you want your AI application to be grounded to that specific data set or knowledge base only, and not to the whole public data, so that when you get the responses, those are more accurate, it doesn't hallucinate. So that's time Foundry IQ will come into the play, right? So with the help of Foundry IQ, you can ground the AI response in real enterprise data, because if you are working in financial and healthcare domains, if hallucination would be really, not acceptable, right? So, or any domain, regardless, right? So, uh, if you want to apply RAG, Foundry IQ will come into the play. So and also Foundry IQ also enables agentic RAG, if you see here, right? Where AI agents can actively retrieve information, reason over it, and use tools to complete tasks. At the same time, enterprise access controls ensures the AI respects existing security and compliance policy. So, in simple terms, Foundry IQ grounds AI responses in enterprise knowledge, turning generative AI into reliable enterprise intelligence. I'll hop into the next, which is Foundry Tools, right? Next, we have Foundry Tools, which allows AI agents to interact with real world systems. Generative AI models are powerful, but on their own, they can only generate text and insights, right? So, tools give agents the ability to take action. So, if you have any execution, I would say tools will come into the execution layer. So, if you want any action to be taken upon, right, that time tools will play the role. Through tools, agents can connect to the APIs, enterprise applications, or databases and workflows, enabling them to retrieve information and trigger any action or process, or automate any task. If you want to do that, that time tools will come into the play. So, to build the next generation of agentic applications for your business use case, AI agents need more than just models. They need secure real time access to business systems and tools. Microsoft Foundry enables this by providing a unified catalog of tools and connectors, right? if I'm not wrong, there are 1400 plus pre-built connectors and ability to create custom tools. So that is a great advancement made here as well. And because these tools come with built-in security, governance, and authentication, developers can focus on building intelligent agent logic rather than managing the infrastructure. So in simple terms, Microsoft tools give AI agents ability to understand your business context and act on it in real time. So that's how Foundry tools play a major role here. Coming to the Foundry control plane, which governs the entire AI lifecycle. As organizations deploy multiple models, agents, and AI applications, so they need centralized visibility and control. Right? Without that, they might at the end of the month or the fiscal they'll be handicapped if there are surprises in the cost side, right? Or if there is any security vulnerability. So we need some control plane which will help me govern the whole AI landscape. So this control plane provides observability, allowing teams to monitor agent performance, also the model usage, whether there is a latency, or also even on the system health. It also ensures security and governance, helping organizations enforce policies, managing access, and maintain the compliance. Right. Uh, in addition, it enables fleet-wide operations, meaning enterprise can manage and operate AI workloads across multiple environments at scale. Right. So basically, we can think of Foundry Control Plane as the backbone, operational backbone of Microsoft. Right. Uh, Coming on to the next, if you see, these are the three pillars, right? The evaluations, controls, and monitoring. The first pillar, evaluation, allows organizations to continuously assess how models and agents behave across the entire AI lifecycle. Second, controls focus on resilience, using the same safeguards that powers Microsoft Copilot, right? The platform helps detect harmful content or prompt injection attacks, hallucinations, and bias, right? And finally, the monitoring brings everything together through a centralized signals layer. This allows organizations to track system health, uh, optimize cost and performance, and enforce compliance through integrations, which services like Defender, Purview, and Intra are coupled here. Another critical capability in the Foundry control plane is content safety. At Microsoft, responsible AI is just not a theory; it's a practice. It is a runtime enforcement built directly into the platform. It comes with the suite directly. When organizations deploy AI agents, it's essential to ensure that the responses are safe. Right? It is grounded and also compliant with the company policies. So Microsoft Foundry provides the same customizable safety controls and used in which has been used in Microsoft Copilot, right? So this includes multimodal filtering, right, custom safety policies, and having a block list if you want to control the content behavior. Then there is prompt shielding. Prompt shielding helps detect and mitigate prompt injection attacks or protecting agents from malicious inputs, right? And finally, the protected material detection prevent AI from outputting copyrighted or sensitive content, so that there is no prevention of the original or the source work done by some hard work done by others, right? It's protected, and it can be also a sensitive document, right? So, and also copyrighted document. So in that case, this helps in refraining from producing the content from that source. Together, this safeguards and ensures the AI agents operate safely, responsibly, and within enterprise policy boundaries. So, as in the previous slide, I was talking about responsible AI, right? I thought of discussing this because this is the six principles or by the Microsoft, right? Which is fairness, that AI system should treat all people fairly. There's no biasness there. It should be reliable and safe. Whatever AI systems we are working upon, or the AI application is integrated in our org, it should perform reliably and safely. It should be secure, and it should be enforcing privacy as well, right? It should be inclusive. It should be made for all. It is just not made for a particular group, creed, or region, or those kind of things. So it should be inclusive for all, and it should be transparent about how it is making the decisions, right? Whatever how AI systems are uh, taking informed decisions, it should be understandable to the humans as well. And also accountability, people should be accountable for the AI systems who are developing it, right? So these are the six principles which Microsoft couples into any AI solutions which are being built. Even Copilot is integrated or developed upon this six responsible AI principles. So yeah, at Microsoft, this is another important thing. At Microsoft, protecting enterprise data is foundational to how AI platforms are designed, right? So data is the oil for any org. So in Microsoft Foundry, data is protected both in transit and at rest, because they use TLS 1.2 or higher, ensuring secure communication between services. For data at rest, encryption is enabled by default using Microsoft managed keys. But if the customer wants to have their own keys, which is known as customer managed keys, they can have that. They can definitely have this. Optionally, if you are building an AI hub resource, right? So whenever you are going to a Foundry, right? If you are going to the old classic Foundry, you'll get a chance to deploy AI Foundry resource and AI Hub resource. So if you're deploying AI Hub resource, right, that time there are three additional Azure resources which gets deployed, which is Key Vault, where your CMK is residing, right? Uh, then is your storage, right, which keeps your encrypted metadata, and the Cosmos DB, which maintains the platform metadata and used for indexing. So by this way, if you are deploying any AI hub resource, you will have full control over encryption while keeping the platform operationally efficient. Coming to the next, industry compliance, right? Enterprise AI adoption requires strong alignment with global regulatory and compliance standards. Microsoft Foundry is built on trust foundations of Azure and supports a broad range of industry and regulatory compliance frameworks. If you can see on the screen, there are all this kind of industry compliance standards which are well integrated in Foundry. Coming to the next, Foundry Local, this is a new advancement made. So while working on the cloud infrastructure, right, you can also work on locally. You can do inferencing there, or you can deploy at edge or on prem as well. Due to So this will help you to prevent latency, right? Or if there is any connectivity constraints, right? Foundry Local extends the Microsoft Foundry platform to on device and edge environments. By supporting local inferencing execution, Foundry Local significantly reduces the network dependency and improves the response latency, which is critical for real time and privacy sensitive workloads. So if you don't want to upload that data into cloud, right, so you can do it in Microsoft Foundry Local. So that is also added as a feature here. And uh, so local means your AI is wherever you are, from the cloud to Windows, Mac OS, or any Android device. Coming to the next, so I think I have pretty much covered this. So from cloud to edge, right? That's how Foundry is spanned across, from Foundry local edge to cloud, right? And you can fine tune the policy and apply observability traces and other signals required for your AI workload. So this is how basically the Microsoft Foundry portal looks like. I'll walk you through. If you're in the classic, because now there are something called as new Foundry. You can toggle around. If you To open Microsoft Foundry portal, let me tell you the URL first. It is ai.azure.com So if you open ai.azure.com, it is free of cost. You can open it. So there are two options. Either you can go in classic mode or you can go in new Foundry mode. So if you go in classic mode, you'll be able to see like this. So the overview, in the overview section, right, it acts as a landing page for Foundry project. It provides key information such as project details, subscriptions, resource group, API endpoints, and access keys, which are required to interact with deployed models. Next is model catalog. These are all the model marketplace within the Foundry, which we discussed previously, right? It can be Microsoft, Microsoft directly from Microsoft or from external parties. Then we have playgrounds, which provides an interactive environment to experiment with models. Then under build and customize, developers can create actual AI solutions. Agents allow developers to build AI agents capable of taking actions and orchestrating workflows. Templates provide pre-built starter workflows for common scenarios. Fine tuning allows customization of models using enterprise data, right? If you want to fine tune and have your own resource that has to be or model that has to work upon the solution you're working on, then that time this will come into play. Then there is content understanding, which enables extracting structured insights from documents and unstructured content. And finally, we see observe and optimize, which helps with operational capabilities like tracing, monitoring, right? So this will help understand developers how the AI workflow is executed step by step, and also monitoring about the usage or the latency or the failures, which is critical for any production AI systems, right? We need to have this insight for sure. Then in protect and govern, we see teams can run evaluations, apply guardrails and content filters, and they can monitor the risk alerts here. And in the Azure OpenAI sections, provide direct access to your deployed GPT models, right? I think GPT 5.2 is the latest model, which can be leveraged if you want to deploy and model from Azure OpenAI directly. And under My Assets, developers can manage data indexes, embeddings, models, and endpoints, which are essential for applications such as RAG based solutions. Coming to the next, so there are AI templates, or I should say the solution templates, which are pre-built, right, with high value use cases and technical patterns, as it has been designed for the customers, for Microsoft is hosting, right? So these templates will enable developers to build and deploy at rapid pace, because these are pre-built solutions. These templates will help them expedite the development process, and upon that, if they want to add their logic, they can definitely do this. They can get started quickly with customizable AI templates to support a wide variety of use case in. And if you see here, it has been toggled to new Foundry mode, right? So that's what I was talking about. So coming to the next, right? So everything we discussed so far, models, agent, tools, and governance, ultimately runs on Azure Global Infrastructure. Azure provides a comprehensive platform of GPU optimized high performance compute, storage, and networking designed specifically to support large scale AI workloads, right? The infrastructure allows organizations to train, fine tune, and run AI models at massive scale, right? While seamlessly integrating with services like platform as a service like Azure AI services, Azure machine learning, and open source frameworks. So while Foundry provides a platform for building AI application, Azure provides the infrastructure foundation that powers those workloads at scale. So let me quickly reshare share the screen so that I can show you uh, I can show you how pricing can be found. This is the window. Yeah. I hope so. Constantinos, can you just confirm whether the Microsoft Foundry pricing is visible to the folks? Because this is vital.
All good, my friend.
Yeah, yeah. So this is a landing page for finding the Microsoft Foundry product pricing, right? If you come down, it is just not one SKU or license which you get it, or a one platform price, just one price. You no, that's not how it works. So there are inside no Foundry, we saw there are models, agent services, frameworks, knowledge and tools, observability and trust, which runs on the control plane and local NH. So it depends on whatever the model you're using, right? So if I just open this for the sake, right? So it will take you to the page where the pricing of Azure OpenAI, DeepSeek, Microsoft, Grok, all these models, right? So whatever model you're using, right? If I click on, suppose this, if I'm using a Grok model or DeepSeek, right? This is my input and output token cost, right? Depending on whatever the model version I'm using, right? If I click on Azure OpenAI model, right? So it is again, there is another landing page which takes me, right? And again, for model router, uh, you have to be careful that whatever the service you want to deploy, it is available in that region. So for model router, if you see here, right, it is $0.14 for input per token, right? So that's how you need to understand how the cost will incur depending on whatever zone you're, or geo you're belonging to, or currency your nation has, or continent has. So you can choose that, and it will reflect that pricing. Coming back to the home page, so there are pricing for Foundry IQ, Foundry tools, and Azure machine learning, right? And then observability and trust, right? You will find cost for this as well. So everything has cost depending on your usage, right? If you're using free, then you can have 500 images per month, 500 text records per month. But if you have to use more than that, which is standard web version that you have to use, then this will be the cost for that, and accordingly the other dependent resources. So yeah, that's how the pricing is calculated, and I'll quickly walk you through how to deploy Foundry resource inside Azure portal, right? So I want to create a resource, right? So this is my subscription. I'll choose maybe Azure AI Connect 2026. I'll give maybe AI Connect Foundry. Okay, and I will use this. So by default, your project gets created. This is basically your logical container, which is used for managing the permissions and monitoring the cost and understanding. It's kind of logical container, whatever project you are doing, right? So it will be a sub resource for your Foundry resource, right? And then coming to the next, after filling the basic details. So if you want to store uh, your keys, right? In that case, key vault or application inside, if you want to configure that, you can configure that here as well. And if you are going to use it for you're building an agentic AI service, then you have to select the resources, right? Like can choose the OpenAI model, or Cosmos DB, or AI search, right? Or the storage account, right? And if you see, it's not or, it's and, because we'll have to have all these resources. All three of them would be required if you are going to use uh, agentic service. And then coming to the next, this is how your inbound access will happen, right? Whether you want it to be public, or you want it from selected network, which is basically a VNet or subnet, which that should be able to access, right? And or if there is any IP that needs to be accessed through that, then you have to whitelist that in the firewall, in the org firewall policy. You'll have to apply that settings, or else you have to disable that. This is how enterprise functions. You have to disable it totally. And yeah, you can add so once you select this, you will get an option to create a private endpoint. Private endpoint enables you to bring all of your services into the Azure backbone network, and every network packets travel through the private endpoint only. So yeah, so if you want to deploy with that, and then definitely we need an identity to deploy, uh, or to access the sub resources, I should say, right? Will by default it will grant user identity of Azure AI user role, so that because the developers will require this Azure AI user role. And if you want to manage or develop at project level, then you need to have this Azure AI project manager role. Again, as we discussed earlier, whether you want, by default it will be encrypted with Microsoft managed keys, but if you want it to be with your own key, right, which is customer managed key, so in that case you will have to provide the key vault and the key vault key reference while deploying it. And then finally you can go ahead and create that resource in Microsoft Foundry, right? So once you deploy this, so there might be some basic things which I'm missing. uh Say my reset later. Okay. Okay. Yeah. So for the interest of time, I have already deployed one. Maybe this one we can take this as a reference. And once this is deployed, you'll be able to see this go to the Foundry portal, right? Once you go to the Foundry portal, this is how it will look like, as I was showing you through the Microsoft Foundry, walkthrough. So these are all the options, or the blade in seen in the left blade or the pane, right? So, and if you toggle around this feature, which is on and off new Foundry, so if you click it on, so this will appear as this. And this is what I was talking about, the solution templates. These are the pre-built solution templates. You can use this for expediting your development process. These are tools and connectors. There are 1400 plus connectors across. If you see, that's what, yeah, it was correct, 1400 plus connectors there, which is used for the logic app, right? And also other tools available, whether it's remote, local, or custom. Even here, if you see 1400 plus, also models, right? If you see, there are all this set of models which we had discussed earlier, right? This is how it looks. So depends, and you can compare the models also, what are the capabilities of each, so that you can understand and then take a decision that what are the models that you need to deploy in your in your AI Foundry or Microsoft Foundry portal for your AI workload. And then let me go back to the, okay. uh, yes, let me present again, share screen. Okay, give me a moment. Let me go back to the slide, share screen, and the window. So we saw like how the pricing is done, right? And how to find out the pricing also. And if you are deploying any other resources like VNet, private endpoint, and Cosmos DB storage account, right, or Key Vault, right, you can go to the Azure pricing calculator and you can calculate that from there, depending on the region you're deploying it. So those are all dependent resources, right? So those are not included in the Microsoft pricing landing page, right? So you have to, for that you have to calculate that in the Azure pricing calculator, what would be the cost looking like for the SKU you are choosing, or the tier, what would be the cost for that particular region. So you have to calculate that as well and append that as a into the initial cost, and that is how you will find out the total cost. And I think I've covered the demo part as well, uh, how to deploy Foundry resource through Azure portal. Next is, so if you're kickstarting a journey in Microsoft Foundry and you want to really, you know, uh, put your footprint on this and leverage Microsoft Foundry for developing agentic AI solutions, or leverage only the Azure OpenAI model or any other Azure AI resource also. It can be deployed because now Microsoft Foundry is kind of an umbrella. All the Azure AI services are under Microsoft Foundry itself. So if you want to leverage any of them, definitely you can do it. And these are all the resources where you can get started. Like there are the training modules available from MS Learn, right, and from Microsoft Foundry, and also how you can plan and manage cost, and the Microsoft Foundry pricing landing page, and also the Azure AI infrastructure, right, which is the engine behind hosting such a great platform which is running. And also, if you want, if you are from a developer background, you want to build a workflow, agentic AI workflow, right? You can do that. So that link is also mentioned here. Maybe I'll share with the organizing committee, so that it can be shared with you, so that you can also leverage and quick start your journey in the upcoming upcoming days. Yeah. So yeah, that's pretty much from my side, and I would like to summarize. Like today, we explored how enterprise are moving from AI experimentation to AI production, and how Microsoft Foundry plays a critical role in this journey, and it provides the infrastructure to deploy models, just not from its in-house models, but from other parties, and how the pricing framework operates. So this is how you can take informed decisions while you're building your agentic AI solutions, or any AI solutions you're building for your use case. Uh, so with this, you can easily, it will help you take informed decision and adopt to the platforms. And this way, you can also scale intelligently, securely, and responsibly. And also, this is one important factor, which is economically. So Microsoft Foundry is exactly designed for upcoming future. And please go ahead and get started with the learning resources, so that you can understand, okay, the nitty gritty of this tool chain. So that's it from my side. Yep.
Many thanks, Abhijit. Thank you so much. That was a quite a detailed
Yeah.
presentation, and I think it was very useful for our attendees, whether you are watching this live or you're watching a recording. I think you will find great value in Abhijit session. So thank you so much for being here. Thank you for honoring us you with your presence. I hope you will come again in another event of ours. I wish you a great day, morning or afternoon, and
Yeah.
bye bye,
Yeah.
my friend. Thank you so much for being here with us.
Thank you so much. Thank you so much, Constantinos. Same here. Take care.
Bye
Bye.
bye. Bye bye. Great. Today we are in a flow and many interesting sessions. Next, we have Luis. Luis has been in Azure AI Connect last year as well. And, his sessions are quite a success, I have to admit that. And I'm also identify some keywords here that make this presentation, this session very interesting, at least for me. I'm talking for me now. We're going to find out how to build our own custom evaluator for Gen AI apps, agents, and models using Azure AI Foundry SDK. Azure AI Foundry SDK is the term that I'm identifying, highlighting here. I really want to see what Luis has built here. First, we're going to have a very small break with our video, and we will come back to welcome our dear Luis. Thank you, everyone. Azure AI Connect back in 1.5 minutes. So, let's welcome Luis Beltran, everyone. Let me bring him over. Hello, Luis. How are you?
Hello, Constantinos. Yeah, I'm doing great. Thank you very much. It is a pleasure to be here, same like last year. Thank you very much for the warm welcome.
Pleasure is all ours, Luis. We are very thankful to have you again, and I really liked your last presentation. I'm sure you will not disappoint me in this one. So, everybody, Luis Beltran, he's on the stage now, and thank you, Luis. Welcome to Azure AI Connect.
Again, a pleasure. So yeah, thank you very much for that. So also thank you to the community, to everyone who is joining this session. Please, if you have any questions, if something is not clear at all, let me know. I have the chat right here, so I will be able to answer as soon as possible. Okay, so let's get started with this session from Azure AI Connect 2026. This event is running all week, so please come every day around this time, maybe 2 hours before, so you can also learn about the topics from different speakers, which of course are really proficient and experts. Okay, so we have our topic, which of course is related with artificial intelligence, with agents. I think that during these 2.5 years, maybe 3 years, that's the keyword, that's the term that is everywhere, right? Artificial intelligence. And we try to connect and use maybe the latest model or the most powerful one to integrate it in our application. But then the question arises, do we really know if this choice about the model, for example, or the application that we are implementing, maybe using RAG, retrieval augmented generation, is helping the users. Are they really satisfied? So that's when the evaluation part comes up. So the idea is that we can use some tools, some libraries that the Microsoft Foundry SDK already provides. And it is an extensible platform, so it allows us to create our custom evaluators, because of course there will be different metrics. In some cases, we might evaluate the truthfulness, the groundedness, right? Like how true are the answers that our agent is giving to the users? Can we really trust it? And there are other evaluators, right? But again, the focus on this talk is about building our own evaluators. We have our own metrics or specific domain metrics. Okay, so yeah, my name is Luis. Here you can find me on different social networks. That's the link. I am Microsoft MVP in AI and developer technologies. And yeah, I am Mexican, but currently living in Czech Republic due to studies and also work. Thank you, Hector, who is sending a message in the chat. Thank you very much, Hector. He's also a Microsoft MVP, by the way, from Mexico. Okay, so here are the contents that we are going to cover in this 1 hour. First, a brief introduction, although I already talked about it. I was really excited to start the topic. So yeah, I already mentioned a few things. Then we will talk about the solutions that already exist in the Microsoft Foundry platform. Of course, that still takes us to the custom evaluators. There are basically two types, which will be, let's say, we will have examples for them. As you can see, code-based prompt-based evaluators. It is also possible to integrate them. This is not 0 or 1, black or white, like you choose code or prompt. You can actually choose both if you want them. So we will integrate them. And finally, we will talk a bit about best practices and some conclusions. By the way, these examples and code that I will share is already available in a blog post that I created last year. So and it is still accurate. So yeah, the code, the GitHub repo, everything is available there. Okay. All right. So short introduction, right? So building something with generative AI has never been easier. As we have seen during this time, we can start developing an application. Then we choose maybe some model, GPT, DeepSeek, Grok, whatever. Then we maybe already have some code, some APIs, some tools. So we plug them into this application. Maybe we didn't start from scratch. We clone a GitHub repo, and then we modify it. We customize it. So we have our own chatbot solution. Or maybe Copilot in agent mode, or all these AI tools generate the code for us. Okay, so we have something. But then what happens when we push it to production? When it is solving now a real-world issue? Of course, the real world is more complex, has its own unique, for example, prompts. Maybe while we were developing the application, we tested a few prompts, and we had some happy path that everything was clear, successful. But then the user is very clever, very smart, and then they try different prompts. Maybe using different languages, right? We tested everything in English, and then the user, they just want to ask in Spanish. Why not? So this maybe POC breaks, right? No longer works. So this production system needs to, oh, by the way, sorry. I am facing some issues here. Give me a second. I am sharing my screen again. Sorry about that. I think it got disconnected. Just a second, because again, hopefully it will not cause trouble again. Thank you. Okay, greetings to Umberto, who is also in the chat. Okay, let's come back. So yeah, there are some issues, maybe token usage. We want to optimize the cost, right? Maybe our application is facing compliance issues. Perhaps the users are trying to, again, break our system. So it ends recommending competitors, or maybe it breaks the law because we didn't test some edge cases. You know that there are regulations everywhere, also depending on the kind of data that we use. If we are, for example, developing some chat application for healthcare or hospitals, there is the HIPAA, right? Regulation. Okay. Give me a second, because I don't like this. So, sorry. Let me move my presentation. Yeah, I think my cable has issues, my HDMI cable. But just a second. I will probably take my presentation to some desktop, and hopefully you will be able to see it. Just a second. Maybe here. I will try to share window instead of screen. Okay, there you go. Hopefully you can see it. Okay, thanks. Okay, so yeah, anyways. All right, so yeah, we see that in production, our application is facing issues. And we want to, of course, before check our AI-based app before it is released to the public. So we need to know what to measure, right? We need to know if we will focus on, for example, how helpful is the application. Maybe we want to evaluate the length of the answer, or maybe we want to check against a data set if the chatbot is giving true answers, right? How correct, accurate is it, or how compliant? Because again, we can test a lot of things. So yeah, of course, this takes us to the Foundry ecosystem, where, for example, we have tools for developing. We have a model catalog. We can choose from more than 11,000 models from Microsoft and partners like Grok or X, Grok, DeepSeek, open source models from Hugging Face, SLMs from Microsoft, like the Phi series. But besides, we also have, let's say, some capabilities that Foundry gives us, like content safety, for example, cognitive services or AI services. Now they are known as AI services, like integrating speech, translation, vision, fine-tuning our own models, and of course, the evaluation part. Yes, we can use the Foundry UI, the website, the Foundry portal, but of course, there is also a way, there is also an SDK, because sometimes we want to create a resource or some evaluation projects with code, right? That's the importance of the SDK. So yeah, we have Foundry as a platform toolchain for, it is focused into development, application development. Right now, there is a new UI, of course, which is centered around agents, right? In this case, I will use the old, or well, let's say old or current, because the new one is still in preview. But yeah, for this example, I will use the current or old portal, but again, using the SDK. So we will see the results in that UI. So with the SDK, of course, we can deploy models, we can create agents, we can submit evaluation jobs. Right. And there are different flavors of Python and also .NET, but specifically for evaluation, only the Python SDK supports custom evaluators. I would mention that there is, I have seen on LinkedIn an evaluation project from an MVP, Jose Luis Lamilla or something like that, from Switzerland, but which is done in .NET, but I haven't tested it, I haven't checked it, but maybe it's a solution for .NET World. Anyways, with the SDK, then we can integrate these observability capabilities. Observability is, let's say, a word, or it comprises several tasks, right? Monitoring, like, for example, if we ask an AI based application some question, we send a prompt. What's the path it follows to deliver the answer? Which tools it called? How many requests it sent to the model that we deployed? How many tokens it consumed, input, output, how many of them were generated? The governance, for example, the documents that it were used, if they are aligned, for example, with permissions, or also maybe compliance, right? That the request leave or the traffic is within some Azure region. We can, of course, customize, but again, the focus of this talk is about evaluation. And this is just one step in the LLM ops. We can call it LLM ops life cycle, right? You know, there is DevOps, ML ops, Gen AI ops, And yeah, here we can mention this one as LLM Ops or Gen AI Ops, right? We develop an application and it's a continuous life cycle of improvement. Okay, so we mentioned that in Foundry we have evaluators, or the evaluation is possible. And essentially, they are under different categories depending on the metric that we want to evaluate. So typically, or maybe the four most well-known are the ones that you see here on the left. Give me a second. Which are these: groundedness, coherence, fluency, and similarity. Groundedness is quite essential. We want to know, especially if we are implementing RAG pattern, like if we are connecting our AI application with our data, we want to know if the model is smart enough to bring factual, true answers. If the user asks a question that involves, let's say, consulting different sources, did it bring the true answer, or did it made it up the answer, right? Did it hallucinate or fabricated the answer? So yeah, with a ground truth data set where we already have some questions and answers that we know that they are the truth, we can then evaluate by using another model, right? The generated answer with the true answer. And we can have some score, right? How many correct, how many incorrect answers. So that's the groundedness evaluation. So in this case, that's also the metric, right? There is a groundedness evaluation. We are testing how how accurate the accuracy of the model. But even some questions like, imagine that we are developing an application, an AI-based application, where the model helps us to, I don't know, to recommend some product. And we add, of course, in the system message, something like, or in the instructions of the agent, do not engage with the user if they ask questions about different topic like politics or sports. So if we ask, maybe some user asks the question, which do you prefer, Madrid or Barcelona? The chatbot should not reply, right? Should not engage with the conversation. Maybe you should say something like, I don't know, because I am already only focused on product recommendations. Even that can be included in our ground truth data set. You question, what's the best team in the world? Answer, I don't know. Yeah, that could be correct and can be evaluated. Okay, anyways. So there are other evaluators, again, like coherence, what kind of, if all the sentences are like consistent or are coherent, yes. Also like fluency, if the vocabulary that is used is correct or not. So yeah, we are evaluating different metrics, and those are valid, right? It depends on maybe the domain, or it depends on what the customer, what the organization is looking for. So yeah, those are under quality, but as you can see, there are other categories like risk and safety. For example, if the application, if the agent is not producing violent content, or it is not recommending self-harm or sexual or different other categories, even protected material, like it is not producing copyrighted text. So yeah, we can also evaluate that. Regarding the safety, for example, there is the red teaming evaluation. So in this case, we can detect, we can evaluate if some, let's say, prompts can be detected as trying to bypass the instructions, the security of the model. Yes, maybe we are trying to attack the model, we are trying to make it change the rules, but yeah, we can detect those cases before, let's say, they happen in the real world. We can make our application resilient, yes, strong against those attacks. So yeah, of course, you can evaluate models, you can evaluate agents, right? And especially for agents, you can evaluate more powerful things like, for example, tool call accuracy or intent resolution. Intent. Well, one of the main characteristics or features from LLMs or language models in general, large or small, is that they are really nice at detecting what the user wants. That's the intent. So, of course, maybe in our application, we have different cases. What the user wants. If they are trying to get some recommendation about maybe financial operations, they will follow this path. If they are trying to get product recommendations, they will follow this other path. If they are trying to, maybe they are asking some question about getting some how many leave days they have, correct? So they will go to the HR agent, something like that. Yes. So we can prepare again some data set and test with different questions, right? If the agent, maybe we implemented some multi-agent orchestration pattern, and we want to know if the orchestrator is detecting the right intent, is routing the query from the user to the right agent, to the right expert who is able to handle those. That's the intent resolution. And tool call accuracy, okay, now that we know what the user wants, is the correct tool invoked? Like, we want to know about weather, we want to know about some product recommendation. So we check the product database. Yeah, exactly, something like that. So yeah, we can evaluate a lot of things. I already mentioned quality, also about security. Nowadays, they have added a lot of things. This is already supported by Foundry. All these kind of evaluators, they already exist. Yes. So we can check for violent, hateful, self-harm, sexual, prone injection attacks, different categories. They are already there, and they support different metrics, different kind of evaluation. So we can use the SDK for that. And we get a really nice, let's say, dashboard where we can see the results. For example, this is a red teaming scan, red teaming evaluation, where we can see how many attacks were successful. So that means that we might need to maybe use different model or improve the agent instructions or the model's system message, so the attack rate is lowered, right? And we can see, for example, which categories we evaluated and what errors we got, right? There is also data and logs, so we can know, okay, which of the 90 attacks, for example, broke the self-harm evaluation, right? Which ones were successful? So that means the model was not able to detect them. So we can be prepared for the issues before they happen. Okay, now our topic. Sometimes these general evaluators are not enough. They don't cover what the customer wants. They are not aligned with their goals. Maybe we are developing a chatbot, but we want to know how useful was for the client, right? We are not caring at all about the answer itself, but maybe how clear or how was the experience of the user, right? With the user experience, yeah, this might be a bit related also with the application itself. But let's say that we want to just focus on the model's answer. And for example, how long, how short it was, and maybe not caring at all about the vocabulary that it used, if it was true or false, right? We want to maybe evaluate the length. And because maybe according to our users' feedback, a concise answer is preferred. We don't want chatbots, applications to generate really long answers because the users will not read. Maybe this is our use case. Okay. Or second example, right? Medical assistant. We want to evaluate how professional was the tone, right? How polite, how comprehensive, if it used terms that everyone could understand, or it was too technical. Again, those kind of evaluators do not exist, but the Foundry SDK allows us to create our own evaluators for our own needs, right? So that in that way, we can align the evaluation with the user's goal, targets, expectations. Okay, so there are two types of custom evaluators, code-based and prompt-based. What's the difference? First of all, for code-based evaluators, you define the rule, the criteria, the metrics, the code. Here, you need to write code to evaluate the string, the answer. And typically here, you will use some functions. You might need to use maybe regular expressions. It's up to you. You are the judge. I will show an example with code and we will test it, right? But essentially here, you don't need an LLM. These are faster evaluations rather than prompt-based. But again, they are not competing against each other. In one evaluation set, you can have both if you want. These are just choices, what you can do. So in the code-based, you define everything, what you want to evaluate, how you will write code for that. The second one, prompt-based evaluator, in this case, you will use a language model. Maybe I have some mistake here, not exactly a large language model, because it could be a small language model. Oh, sorry for that. Okay, yeah. Anyways, you use a language model to evaluate the answer. So in this case, it means that they will be a bit slower because we need to send, right, a request to that model. And it depends if this model is hosted in the cloud or locally. Anyways, yes, you define the rules, but the language model will evaluate the answer according to your rules. So essentially, it's like you are creating a judge agent or judge model. You are instructing the model to assess some string, some answer, maybe which was generated by another model or which was the output of some agentic process, typically we define the criteria, the rules, using natural language, and you will see how we will do it. Well, actually, I have this in a .prompt file, right? Again, I will show you examples. So it is possible that in your evaluation, you need both or only code-based. This is up to you. Like if you can evaluate using code, perfect. But if in other cases you need to evaluate something related with quality, right, or alignment with some professional tone, it might be difficult to do that with code. So we will leverage that task to a language model. So let's start with code-based evaluator, okay? So this is the example. This is the code. I will show you, show it running in a minute, but just so you can have a clear idea about the code that we need. As you can see, we are using Python and we are defining a class, let's call it Clarity Evaluator. We want to evaluate, for example, again, this is some rule that I define. This is up to you. This is an evaluator that doesn't exist in Foundry. So we want to evaluate the text clarity, okay? And text clarity for me, for our own scenario, we said, okay, we want to check how long is a sentence. So if the sentence is long, we will consider that this is a bad answer, maybe, right? And we also maybe want to check how many words are in each sentence, okay? So we can use code for that. We can use Python regular expressions to determine, okay, we use some symbols, signs to determine the end of a sentence, right? Question mark, exclamation mark, dot. And essentially, yes, here we define our metrics, our calculations, compute, whatever. We don't need an LLM to do that. I mean, we can, but we can also do it with code. So yeah, this process is fast, doesn't require LLM to run, can be implemented in a pipeline. But again, it is up to us to evaluate what these numbers mean to us. In some scenarios, a short answer is perfect because we are looking maybe for specific data. But in other scenarios, a short answer means bad quality because we expected a detailed description, right? So yeah, it depends. Okay, let me show you this one so we can see. But again, in this case, I think I will ask Konstantinos if, okay, just a second. I will share, let me find Visual Studio Code. Okay, just a second. And let's switch. Okay. Hopefully you can see my screen with code now. Thank you very much. All right, so yeah, let me show you this Clarity Evaluator class. This is essentially the same one that you saw in the slides, Clarity Evaluator. But there is some code that I did not show you, right? So here, yes, you saw the class with the method. But then again, I also have a clarity evaluation where I submit some answer. For example, this is answer 1. The process has 3 steps: first step, second step, final step. And there is answer 2, right? In order to achieve the objective, it is necessary that the applicant blah, 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 right? So even though this is multi-line, there is actually just one sentence. This is long answer with one sentence. And the second one is shorter, but it has more sentences. So here we can just invoke our evaluator, right? Which is the clarity evaluator, right? As you can see, we don't even need any SDK here. It is quite simple. Clarity evaluator. This is our class. No packages, no libraries needed. Of course, maybe you can add your own if you want. And when we run this, Python clarity evaluation. Yeah. Here we get the first one. Okay, average sentence length is 525 words, right? So that means, let's say 5 words per sentence. And we are detecting long sentence ratio. In this case, in the clarity evaluation class, maybe we define this rule. If there are more than 25 words per sentence, then we define it as long. And less than 25 is not long, short, right? So yeah, the long sentence ratio in this one is 0. But for the second answer, which is quite long, because you can see there is only one dot here, the average sentence length is 55 words per sentence. This value is greater than 25, thus the long sentence ratio is 1. And again, it is up to us to define, okay, what does this 0 and 1 mean? In some cases, 0 would mean success or clear answer. In other cases, it would be the opposite. But again, what I want you to focus is that here you define the code, you define the rule, you define the meaning of your metrics. This is, in general, custom evaluators, they align with your goals, with your objectives, okay? And now that we are here in VS Code, let me show you the prompt-based evaluator. So for the prompt-based evaluator, we need 2 things. Let me show you. First of all, we need a prompty file, .prompty file. Prompty is some format which is quite used by several Microsoft technologies. And essentially here, this is from YAML, actually. It uses YAML. Maybe this will be a bit familiar with you, or familiar to you, sorry. So essentially here, we define, for example, name, helpfulness evaluator, what it does, the model, right? I already have a .env file, environment variable, right? So this is already connected to a Foundry project resource, an OpenAI endpoint, and of course, we also have the key. And for the moment, let's consider that we are using one model, okay? Model evaluation deployment GPT-4.1. So this is referenced here. So yeah, this very first part is just configuration, definition for this, for the model that we are going to use. But here in the text, this is where we use natural language. That's why they are called prompt-based evaluators. We use natural language to define the rules, to define some criteria. Here you can see You are evaluating the helpfulness of an answer. How helpful, how the user will feel that this is what they need, that they will follow some steps and they will fix some issue. Of course, we can be as descriptive as we want. And we can add examples. So here you can use your prompt engineering, for example, techniques that you know. We are clear, rated 1 to 5. 1 means not helpful, 5 is extremely helpful and actionable. We can even, because again, I told you, we can use prompt engineering. We can even say, return the result in a structured way. JSON, okay, score 1 to 5, reason. But if you want to return XML or just some text, feel free to do it. If you want to generate some CSV, yes, you can do it. It is up to you. Here you define the rules, but you don't code it. You simply use natural language. And yeah, we will get some output. And of course, we are using some parameters, like for example, the generated query, the answer, the response. Here is the answer to evaluate response. Of course, you will need code, but to connect to these prompt files, to pass it to the judge model, right? So it can assess the answer that we are going to send. But the core of the prompt base, which is the second type of custom evaluators, is this prompt file. Because then I will show you. Here we have, oh, sorry, I forgot. This is the helpfulness evaluator class. But essentially here in the helpfulness evaluator class, I am just connecting the dots. Here you can see that we are using a prompt flows to read the prompt file. By the way, I will show you eventually the requirements. But here, for this one, we have used so far python.env and prompt flow libraries, right? So you can install them later. Anyways, so in the helpfulness class evaluator, we just define the class, and this is the method that we invoke. So yeah, here you can see load the prompt file, passing the model configuration, and we just return the result. If you remember, it returns a JSON, so we simply send it to the output, right? We return it. JSON loads, LLM output. In case of error, I fall back to score known and reason the error. And the Python file that we are going to run, which is helpfulness evaluation, is this one. Yes. Okay, we prepare the model config that will be used by the class. We create our helpfulness evaluator object, and we are sending 2 answers. Okay, the first one. To reset your password, go to login page, click forgot password, follow the instructions, blah, blah, blah. So this is one answer. Again, this answer will be tested, will be assessed against the how helpful this can be to the user. And the LLM already knows that's, okay, this sounds helpful, but let's see how much. And this is answer number 2. I don't know, maybe try something else. If someone says that to us, yeah, that will be unhelpful. We will not like this answer. But let's see what the LLM judge thinks about it, okay? So yeah, let me now show you this second example. Python helpfulness evaluation. And you can see that it takes some time because, of course, it is sending this request to the model. And here you can see For the first one, the first answer was helpful with a score 5. And typically the LLM will emit a judgment, will emit some reasoning, right? You know that LLMs like to talk. So here we see the reason. The answer provides clear step-by-step instructions. That's why the score is 5. And for the second one, the I don't know, was unhelpful answer evaluation, score 1. Reason: the answer does not provide any useful information, blah, blah, blah. Okay, again, this was very short example, but now imagine, and you might think, well, I don't need an LLM to do that. But then again, think that maybe you need to evaluate thousands, maybe hundreds of thousands prompts, answers, right? So yeah, that's where the power of this compute can help. And again, we can even prepare a data set with the answers of the different users and maybe integrate it in some pipeline, right? CI/CD to get some metrics, some scores at the end. How many questions were answers were helpful? How many were not? And maybe here we can test, for example, the effectiveness of RAG. Perhaps we feed our model or agent with documents for troubleshooting, right? So then the user asks questions. Okay, my coffee machine doesn't work. It is so some LED is blinking. Okay, so then the model, the agent, can reply, can provide some answer according to the documents that we prepared during the RAG or maybe fine tuning, and it will provide some steps that the user can follow. But maybe if the training was not enough, was not successful, perhaps the answer is not useful at all, right? So this evaluator will find it out, and we will see it eventually in the metrics. Here you can see the score 5, 1, and so. Okay, and now that we are here, to avoid any other change, so we have prepared code-based and prompt-based evaluator. Can we integrate them into maybe some pipeline, or maybe do a script that runs both evaluators? And this is, we can do this locally or in the cloud. So I have this file, local evaluation, which typically does the same that we would do for evaluators that already exist in Microsoft Foundry. For this example, the final one, local evaluation.py, please notice that I am using the Azure AI evaluation. This is from the SDK, and this one also comes in the requirements. Azure AI evaluation. So once we install this library in our virtual environment, for example, we can use it with the SDK. This is where we are actually using the Foundry SDK. Okay, so I have also prepared this dataset.json lines. It's a JSON lines file. This is important. It is not JSON. This is not an array of JSON objects. It is JSON line. JSON line means that each line is a JSON object. You can see ID and response. The files, you can name them, the properties, you can name them as you want. Maybe this one is key and value or answer or whatever you want. And again, and there are no commas between every object. They are JSON lines, okay? But please check that, for example, essentially here we have a response, right? Here are the answers, what we want to assess in our pipeline. For example, The process has 3 steps. First, submit. Second, wait. Third, attend schedule appointment. Another one. In order to achieve the objective, it is necessary that the applicant, blah, 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 to reset the path. You can see some strings, answers. This data set is what we are going to evaluate. This is the target for our evaluators. Then we create instances of our custom evaluators. You can see clarity evaluator and helpfulness evaluator. If you remember, in my case, for my helpfulness evaluator class, I need the model configuration. And for the model configuration, yeah, I use the environment variables file, right? So I provide the endpoint, the deployment, and the key. This deployment, this is the judge. This is the LLM, sorry, the language model, because it could be language large or small. This is the model that it is going to evaluate, judge, assess each of these strings. The ones that you saw here in the data set, okay? Well, now that we have that, we also provide our project endpoint. This project endpoint, this is from the Microsoft Foundry resource. And this method evaluate, this one comes from the evaluation SDK, right? If I control click here, this will take me to evaluate.py. This file comes from the Azure AI evaluation library. Yes. Okay. And essentially here I provide the list of evaluators that I am using for this assessment. I can use custom or built-in evaluators. Here I am adding clarity and helpfulness, but if I want, I can even add some groundedness evaluator, coherence evaluator, whichever I want, right? And this is just the key that I am using, because this will appear later in the results and also in the Foundry portal. If you remember, we are providing a data set, a JSON lines. So it is important that we, for our evaluators, we indicate, we say, okay, this is the column where you have your answer or your response. It depends on what you want to evaluate, correct? Okay, so yeah, of course, the property response from the data, this is what we want to evaluate, because maybe our data set has multiple different properties. Anyways, and that's it. The evaluate method will process according to the evaluators, the code that we included, the individual test that we run a few minutes ago. They will be handled by Foundry, but our resource. This processing will happen locally, because this is a local, local assessment. But the results, we can get a local copy of the results. A file will be created, you will see. And also, these results will be uploaded in Foundry. I will show you, or there will be some URL. Okay, yeah, actually here, output path. Let me change this one. I will call it live results. So you can see that the file is created. And yeah, the endpoint. And that's it. Let me just change the name of this one. The file doesn't exist. And now, let me show you local evaluation.py. Okay, so you can see there isn't a file here with live results. Let's run it, and it will start then using the Foundry SDK. And here we can see the logs. Okay, here is the test, for example, helpfulness evaluation, and eventually clarity evaluation. The evaluations are saved here in this live results. Okay, this is the green file, and we see essentially the same information that we have here. Here you can see inputs, for example, the first one, right? Inputs ID, the response, and this is the judgment. The process has 3 steps. First, oh, I'm sorry, this is the answer. Sorry, this is the answer from the data. And then these are the metrics. If you remember, for clarity, the sentence length, the sentence ratio, helpfulness score. For example, the LLM determined that this answer was middle level helpful. The answer provides clear basic outline of the process, but lacks detail about what to submit and so, right? Essentially here, please notice that we are getting the metrics of both evaluators, clarity, these two, and helpfulness. We are in one assessment combining both, but this is only for the first answer. If you remember, in my data set, we had 4 strings. This is just for the first one. And then we also have the second one. Okay, the sentence length is 21. Long sentence ratio is 0, because if you remember, the limit is 25. Helpfulness, how helpfulness, what was this one? 2. According to the LLM, the answer is incomplete. So yeah. Well, I want you to tell you, just before we finish, because we are almost out of time, that here in the logs, we are also able to see a URL. This URL, let me show you. And yeah, this is just the last switch that we are going to do. So I will ask again, Constantinos, if we can do. This is the final switch, and then we will wrap up this session. So let me just share the window. Hopefully you can see it. So this is just the results that I show you on Visual Studio Code, but now in the Foundry portal. This is a test that just ran 3 minutes ago. We have the evaluation details. In general, this is the average of the clarity, the average sentence length, long sentence ratio. None of the answers that I provided in the data sets were long, okay? And the helpfulness score, 2.75. From the 4 answers, the average is 275. And we also have data. We have each of the responses, the different scores that we got, clarity average sentence, clarity long sentence ratio, helpfulness score, and also the judgment. And we also have logs. The same file that I showed you on VS Code, we also have it here with the justification. Yeah. But yeah, essentially here you should also see some. Oh, okay, it didn't show a chart this time. Okay, maybe next time, or it will take some time to prepare them. But yeah, we could also get some plots here. Okay, so yeah, essentially this is what I wanted to show you, that you can create your assessment, your evaluators that you need for your solutions, because perhaps the built-in evaluators that Foundry provides are not enough. Fortunately, the platform can be extended to cover our cases. Okay, so yeah, with that we conclude this session. Hopefully it was interesting for you. Please, if you have any questions, any follow-ups, I will be glad. I'll be happy to answer.
Wow, Luis, that was really amazing. I really enjoyed that. Of course, I'm going to have to review your session, re-watch it, and everyone can with the recording on YouTube. But I really like your technical style and your deep expertise. And yeah, we're very happy to have this session this year with us.
Thank you,
Don't
thank
see
you.
any
I will
questions.
share the link in the chat, just in case you
Please,
want to
yes,
check later, or if you want to share with the audience. So yeah, feel free.
yes,
Okay.
please. Wow, amazing. So everyone, Luis Beltran with us, second year. We are very happy and we really appreciate Luis coming over. Wherever you are, you can also watch this really amazing session. Our next speaker is already with us. Luis, we're going to say goodbye to you. And many thanks, my friend. Hope to see you again real soon.
It was great to be here. So thank you again, Konstantinos, for organizing this event. All the best for other speakers, and
Thank you.
also for the audience. Enjoy the event. Bye bye.
Thank you. Thank you. Bye bye. Great. I really enjoyed this day. It's quite great, as a host to see every speaker coming in and delivering such amazing sessions. And I'm sure that Lorenzo Sada Hiris, if I'm pronouncing correctly, is going to do the same. I'm sure he won't disappoint us with orchestrating guardrail multi-agent systems on Azure AI Foundry. Pretty related sessions, a little bit different, of course, because our experts have their own, way of delivering their sessions and experimenting. And what I want to say basically is that what we're seeing people that are curious, right? We need curious people to go to the long run, to take that extra mile. I know that all of our speakers are spending time from their personal time, so we can learn, so we can find new things, interesting things, and apply them even to our jobs or into our demos, or if we do it for fun, even to our fun or hobby, um, you know, uh, occupations, whatever we do. But I really like the fact that our speakers are curious and they have reached the level where they are now experts. And we have Lorenzo with us, another expert coming to Azure AI Connect. Just a short break, 1.5 minutes with the video, and we're back with Lorenzo. Thank you, everyone. You can see the recordings, as I said earlier, in our YouTube channel. In case you missed any of the sessions, they will be there uh, for Azure AI Connect 2026. Thank you, everyone. Back in 1.5 minutes. Great. We are back, everyone. Azure AI Connect 2026. This is our second year running Azure AI Connect, and I'm really glad that I have narrowed down the speakers. It is very challenging to manage, like last year, 45 different sessions with almost 50 speakers. It's really challenging. Of course, it is very interesting to have more sessions because you are getting more information. But for me, which I'm a solo person running the community of Global AI Athens, at least at this point in time, I think 25 speakers are great. One of them is Lorenzo, and let me bring Lorenzo in the stage, and welcome.
Hi, hello. Thank you very
Welcome,
much,
Lorenzo.
Constantinos.
How are you? Where are you calling from?
Right. I'm based in the UK right now, in Exeter, the University of Exeter.
Perfect. You are from UK, and you're going to show us about the Foundry and agents. Is that correct?
Yes, mainly orchestration framework and how agents can work together.
Amazing. I saw your LinkedIn profile. I believe you are quite an expert here, so we can't wait for your session. The stage is yours, my friend.
Okay, thank you very much. So let's get to my presentation so we're all in line. And thank you very much, Costantino, for organizing this event and also for the introduction. Share screen. You'll be able to see my screen. Okay, perfect, amazing. Let me get mine. So today we're going to look at orchestrating guardrail multi-agent systems. And I want to start with an analogy. Let's say you are in a car and you just sit down in your car and you're ready to start. And just while you're starting to drive, you realize there's no steering wheel and then there's no brake, there's no control, you're going full speed. And now you take that, you look around and you see there's 40 of these cars just around you. And that's what we can have a multi-agent system that is not guardrailed in production. So what we just did is we enter a car, it's our agent. We think it's all safe, everything is good, but then realize we don't know how to steer it. There's no brake, we don't know how to stop it. We look around, there's actually multi-agent systems, there's 40 of those agents all around us. And today we're going to talk about this. How do we make sure that this does not happen? And I want to raise a virtual hand here. If you heard about AI agent, and this is a bit ironic, obviously, it's the buzzword. It's all around at the moment. A lot of AI agents, and we've gone a long way from the initials where you took a prompt and put that into an LLM. Then you had your AI agent. Now we've got, ChatGPT browser was one of the pioneer, and now it's so much change that we're at OpenClaw, where we can buy a Mac Mini. Don't do that. Just get a VPS. It's much cheaper. And you can run your own 24-hour autonomous agents with soul documents, heartbeats, with MCP integration, and all of those really good words that represent technology and lots of advancement. It's crazy to think that the MCP, which is now such an established technology, is a bit more than a year old, a bit more than that. So it's all quite recent and all moving really fast. And then maybe what is even more interesting is raise your hand if you've actually built an AI agent, not only used, but actually built your own, put your hand dirty into learning what are the various aspects of agents. And even more, if you actually did in productions for a company where they actually add an ROI from having a multi-agent system, or even a simpler AI agent working and improving their workflows. And we're just going to start with looking at some definitions in order to make sure that we are on the same page and we know what we're talking about. So obviously, an agent, which is an LLM equipped with tools. Agents have been around for much before LLMs, obviously, but at the moment in this conversation, we're talking about LLM-powered agent, or at least agents when there is LLM somewhere. You can have reactive or much simpler deterministic agents, obviously, but the main idea from an agent is that they have agency, is that they perceive an environment and then they make reaction, either reactive or proactive, into that environment. So that's our foundation. To have a multi-agent system, well, you need to know what an agent is. Then when you have multiple agents, that's where you get the multi-agent system. We have multiple, at least two or more, agent with distinct roles. So it's not just a copy of the same agent. It's multiple agents that specialize and then talk and work together. The tension here, and what is actually interesting, is, well, how do we make sure that our multi-agent system actually deliver ROI? How do we make sure that they're actually better than just an agent or workflow or simple things? And how do we leverage the advantages of multi-agent system, which is obviously the specialization, the granularity, and more, without falling the drawbacks, so multiplying the surface of risk, the complexity, or the cost. At the same time, we also have something even more advanced, which is the agentic system, which is similar but sometimes a bit different. So it's a system where you have agents that operate within that system. that then can also be even more autonomous. So selecting their own tools, doing their own things, and then you just go and look at the results. We've seen, for instance, really interesting research in Minecraft or simulated environments where you have fleets, swarms, that's the technical term, of AI agents all working together for achieving specific actions or simulating societies. We've seen now research also in terms of how LLM will actually run governments and what they will do if they actually run an entire government. And now I want to look at two more terms that are really important in multi-agent system, which is orchestration and orientation, which are two really important O's in the multi-agent system, because the first one, orchestration, is what allows multiple agents to work together. The foundation of having a successful multi-agent system, we're going to look at that in a research that looks at what makes a successful multi-agent system, is orchestrating. So making sure there are multiple brains communicate correctly. And this is also interesting because it is similar to things in human groups where you need communication. And if you don't have a distributed amount of talk or distributed amount of intelligence, you get a reduced output. And then the second aspect is orientation. Orientation means you need to have a good direction. And this is the car example. If all the cars are going in random direction, you don't have actually a movement that is uniform towards the direction that you actually want to give. And this is where when you have a task, you need to make sure that your agent work together in the right way and in the right direction to achieve that right goal. And then finally, the last term is guardrail, and that's why the title of this session is in 4 words. The core section is multi-agent orchestration, but guardrail. Why? Because if you don't have guardrails, you don't have the multi-agent. You don't have the working production. If you don't have the brake, no one will ever go in a car. And that's why it's really important to have what's called safe AI, in sense, having safe agents that actually have guardrails, bounded by policy, with rules, and making sure that high-risk actions are protected. And this is what, for instance, the OpenClaw open source community is realizing. OpenClaw is amazing, but per se, without guardrails, it has really, really strong limitations. I will never, never, never advise to put OpenClaw on your root computer and just let it run. There's a really high potential through prompt injection and more that it just can erase your computer. And we've seen it happen in production from Replit, from Air Canada, from even Claude examples. So it's really important to have a multi-agent system that is guardrailed, orchestrator, and orientated. So now that we have our definitions, which I guess we've already seen also in previous talks, we can then combine that to look at the actual components of those. One point I wanted to take just to start is the difference between workflow and agent, and it is quite important. And this is what makes kind of the interesting aspect of agents. Whereas a workflow is a set of instruction, raise my hand, say hi, an agent has agency. It can actually make decision per se. It's not scripted. Obviously, you can have agents that are more linear in creation, but the core advantage of an agent is the aspect of autonomy. And then when you combine that with oversight, the guardrail, that's where you get powerful agents. So this is a really important distinction to make that will allow us to then look at these various aspects of agents and what constitutes an agent. And then we're going to build our dream team. So like imagine like if you play FIFA or a football game or even sports game, the whole point is you get that card and you get that card, and that's building an agentic team. So making sure you get the various agents, they work together, and that's how then you can build meaningful automation at scale. You look at companies that have done this successfully in OpenClaw, obviously, but also more niche kind of sales stack multi-agent system or marketing multi-agent system, or even and now over 50% of the use cases in AI agents are actually in development. So when you look at successful, for instance, Copilot or related multi-agent system or Claude Code, they all have this kind of aspect of having this orchestrator usually brain in the middle that is smarter. And then you delegate with various ways, which we're going to see in this talk, the information or the task to do to sub-agent. So in a certain sense, it's kind of creating your dream teams. You create agent card, you see how they talk together, and that's how you build your multi-agent system. That's how you orchestrate your multi-agent system. So the goal of this talk is really going through all the steps that we need to go from just agents or what we know and what we've seen to an actually working guardrail multi-agent system in production. And to do that, we have to start by looking at the anatomy of an AI agent and what are the different aspects that we see currently in AI agents. This will take probably around 10 to 20 minutes looking at the anatomy of an AI agent and the threat surface we have. So then we can combine the two core action, which is the agents and the guardrails. So what are the main aspects that contribute of an agent currently? Well, we have obviously, as we say, the orchestrator, which can be either be inside of an agent or in multi-agent system, a dedicated agent. You have the human in the loop, which is the approval case, the oversight, the connection. Now we also see the emergence of soul documents, which are kind of personality documents. OpenClaw has it, Claude Code was the pioneer. I really recommend looking at the actual Claude Code as soul document. We also have tools and MCP. This is kind of the API on steroids. Originally, could simply do it with an API, but now you have obviously the MCP, which makes it more streamlined. You look at context and RAG systems, so how do we interact with the context layer with knowledge? HubSpot, for instance, has released a framework for integrating agents with their knowledge layer, and they call it, I believe, the customer agent protocol, where you actually go and connect agents with context in a really smart way. And then finally, you also need the execution layer. So how do I make sure that my agents are actually helpful? And this is what makes also OpenClaw so successful. It's really easy to install, one. It's really powerful. It can do anything. It can go to my browser. That's also where you have the risk, obviously. And then finally, it's also really easy to interact with. I can just go through really simple human in the loop, just go on WhatsApp, send it a message. So this is where I'm going from building my agent, but literally going from a problem, which it can identify because it has the right context, to asking me questions so it actually solves in the correct way, then does so safely and guardrail to then have the actual execution so it doesn't actually solve the problem. It's if I go to the hospital, it's not just telling me your arm is broken. It's telling me your arm is broken, go into this machine, we're going to give you this treatment based on your history, get this, and now, yes, we also get you a gym subscription to get you fit and strong. So kind of looking at the overall solution, not just a part of it. And we look at examples a bit more in details. I think we can also share the slides, or obviously you can contact me if you want to look. Each one of those points can become a really much larger conversation. But the orchestrator at first, it's what root task and manage states. So it's basically what allows you to move between the various aspects. And it is really important. And usually the orchestrator is a smarter agent. At the moment, Claude Opus or Sonnet 4.6 are the best ones to building this orchestration layer because they are the ones with the largest understanding of strategy that we got currently in terms of models. Although, I mean, just yesterday, we have 2 new models from Google and ChatGPT, but they're all kind of more instant models. In the orchestrator, it's better to usually have thinking models, which will then allow to kind of really understand what you want and then be able to distribute it. And then obviously in the actual edges, in the edge of your system, that's where you can have and leverage open source LLM, tiny LLM. I mean, we've seen Quen 3.5 that now at 9 billion parameters is as good as Sonnet 4.5 in certain benchmarks. So obviously there is the opportunity to save money, save time, and then in the end, deliver higher quality to your users and more optimized if you're actually able to optimize in the agents you use. And this is moving extremely fast. The model I'll tell you today may be a different model in even 2 weeks. But what matters usually is your orchestrator is a higher level thinking brain that has a more understanding of strategy and overall goal. And the more you move into the edges, the side, the more you move into the specifics, that's where you got more restricting prompting, you get more restricting and smaller agent and more active agents, so things that are more specifically for one task. Then obviously human in the loop, this is a term that has gotten a lot of popularity at the moment. The whole idea is that you don't take irreversible actions without human decisions. If you've used, for instance, Cowork from Claude Code, they have this implemented quite well, where for each MCP integration, they have all the MCP task actions. And for each task, you can define if you want it to do automated, if you want human approval, if you want to always use it. We're going to see in this tool actually ways to make it even smarter. So when you have multi-agent system, you can actually use frameworks to make that based on risk scores. So rather than just blocking action because of the action, you can actually block actions based on the risk and based on their importance. But human in the loop is very important because it allows humans to see what's happening. So if we come back to the core, when you want to build your own multi-agent system, you obviously have your various agents, your orchestrator, your sub-agents, and then it's important to think, what are the actions this can do? What action can it just run autonomously? But what action need oversight? And that's where even at the start, from the building side, you can already know what will need to have a human in the loop and what gates to put. And then you can then personalize that based on the actual user that will use your application, which can then decide, oh, this thing, I want it automated, this thing, no, I want it with oversight, this thing, I want to always review it, but in a specific way. Soul document is something that excites me very much because it's quite new, but extremely interesting. And it's a document that is basically higher up in the leverage of prompting. So something that is even higher than a system prompt in a certain sense. And that tells your AI from a philosophical perspective what it matters. And I really recommend trying this and trying to see if there's an impact. On my experiments, for instance, with Claude Code and with Claude in general, it is extremely powerful and it allows to give your AI a more human layer and more importantly, even a philosophical aspect, which is one of the reasons we've seen kind of an exodus to workload at the moment, because it has, say, an understanding of strategy and they've worked with, they have actually someone in the team that is an expert in model welfare that will actually look in the model. And if you look at Claude Soul document, they tell Claude, look, we don't know if you're AGI or not, we don't know if you're sentient or not, but act as if you were sentient. And why this matter in terms of prompting? It's not really that, and I believe that it's not really that they care if the model is sentient or not. I mean, they obviously have all the brand image around that, but what matters is that we've seen how much prompting can influence AI. And we've seen that, for instance, in a research I made myself, I was looking at how the person interacting with AI was changing the output of AI. So if you're a woman or a man, if you're a specific type person, it will actually change based on the memory, change how the AI interact with you. And this opens, obviously, a whole new category of risk and problem. But in terms of soul document, this means that just by telling AI what you want the dream state, how you want the AI to be, due to the fact that it's trained on human documents, it's trained on our data, and it's a lot of parallels to our way of thinking, it will tend toward that. This is the same as the first chatbots, where the first line you gave ChatGPT was, in the system front, was answer like if you were a ChatGPT bot answering. And that's how you got the first kind of LLM predictions. So in terms of soul document, you can give a soul document either to your specific agents or kind of have a general base to your orchestrators at a really high level will tell you, and this is extremely important for open-ended agents. So the more your agent is open-ended, the more you need a soul document, will tell you kind of what persona it is, what it represents. And it is where you can appeal from philosophy, and it's really good for prompting. Then we obviously looked at tools, skills, plugin, and MCPs. These are quite common at the moment. So things such as connecting your agent with search APIs. At the moment, there's Brave API that you can use that is quite good. A code runner. I mean, Manus AI, which has been acquired by Meta, has been kind of the biggest example of this. They literally had Claude Sonnet originally, but they connected it so well with tools and the fact that it can interact with a database, with a computer, the fact that it can take root level actions, that it can spin out its own sub-agents and do actions with them. This is where you get a lot of power. And this was one of the first kind of brick breakage from just this stable, smaller agent to actually multi-agent system that actually perform helpful action scale. And then context knowledge RAG, this is the layer we're talking about that is really important. So making sure that your agent can interact with knowledge. And this is where if you don't have good context, you don't have good agents. An agent is, I mean, we could even say an AI is as good as the data get, an agent is as good as the context as it gets. This is extremely important. It can be obviously vector database, it can be RAG, it can be even simply making sure that it gets the right content in any way, that the technology does not matter, but being able to interact in the right context will make the difference between an enterprise user using or not your agent. And we've seen this with, obviously, Copilot deals with large organizations where Copilot can directly connect with the organization knowledge data set, which saves a lot of time, but most importantly, reduce the friction in adopting an agent. So another example I've worked on is seamless data integration. So you currently maybe use this specific system, and then when you build an agent that allows to do these specific actions, you make it seamless to integrate with that system. And this has worked really well for a startup I work with, where literally done that, where it's just connecting directly, which makes then the output much more powerful, but the friction per se is reduced. And then finally, the execution and action layer, which means that your agent needs to be able to actually do actions, do connection, do things. And this can be done in plenty of ways. I mean, at the moment, we have the chat-based interface is kind of the king. I'm actually giving a talk in a month around how we can move away from chat interfaces, which are being kind of outgrown by agent system. And this is quite important because whereas a simpler kind of LLM-based discussion fit really well because they become more human, we have that interaction. Agents that actually interact with complex knowledge have much more complex ways of giving the output. So these may means, as we've seen now, Claude also is good at it, creating PowerPoint directly, embedding. ChatGPT just released the ability to directly edit SVGs, Gemini with Nano Banana, and creating images directly, really kind of even with Flow, where you can create videos and edit videos directly inside of the platform. So the output is embedded into what you need to work on. But even more advanced, I've, for instance, worked on instant interface generation. So we connected an LLM with a bytecode language that then compiles into HTML and CSS and JavaScript. But the way we built that is that the bytecode language is mathematically reduced. So it's extremely combined. We reached around 85 to 90% reduction over actual web language, so HTML, CSS, and JavaScript. And then we fine-tune an LLM to be able to generate this bytecode language. And then at runtime, obviously, we have a low-level compiler type of compiler. It's not really a compiler, basically something that turns that into HTML, CSS, and JavaScript. And this means that we had sub 1 second interface generation. It is where we're looking at things that are much more interesting, because you can actually have your agent and you talk to it in real time, and things change on the page in real time. So it is a much more interesting way of interacting with the output of an agent, where if you say, create a presentation for this, it actually creates the presentation live in front of you. If you say, oh no, go and find me leads, you can actually see on a list, the list of leads appearing. And then if you say send an email, it connects with the NMCP and it shows the email in the page. Then you see live each prospect being the emails being sent for each prospect. So when you actually build interfaces to make your agent interact with your users, you obviously have the safe choice, and you usually always need, in a certain way, a text-based or at least a chat-based interface. You need a way to exchange knowledge with the human. But at least in the output and in the execution and action layer, there's a lot of work to be done in terms of how do I show what's happening in a browser? And we've seen Comet doing it quite well, where they actually see kind of activating AI vision, and you see the cursor moving around on the page. How do I make the user see, and observability is really important from a user perspective, that things are happening, that there's success. It's not just a call, and 2 minutes later, or even 20 minutes later, you get success. I mean, we've seen it happen with also the agents by ChatGPT in terms of deep research, where they actually show you the AI reading the source one by one, thinking this helps, for instance, as well. And also, finally, the memory unit, which allows to also store interactions over time. So if you have a multi-agent system, you can then connect the multi-agent system to a tenant-based memory unit. So it's obviously isolated in order not to have any cross-section problem. But this allows to then improve your agent based on the interactions over time. You can also do so at a general level if you have anonymized data. But more specifically, what I did research on is how do we make the agent improve based on a specific person? So how do we make it learn through the personality, through the preference? One way to do that we experimented in large-scale education research. So I ran a really large course on AI, approximately 2,500 students in the past year. And we used a multi-agent system to do personalized workshops. So the way it worked is we got them to do some exercise, we learned through how they work, and then we create a persona sheet, which is kind of the memory layer. And in that case, it was hybrid. So in some cases, it was scores. So we infer their personality. In some cases, it was actually text. So this was notes taken by the agent about the person. Obviously, this is similar to how it already worked with ChatGPT and others. In other cases, it's also visual. So how do they prefer the information? How do they prefer to learn? And then the more you actually did the exercises, the more the exercise was based on actually you. So your analogies, your way of approaching the world, your different perspectives. And these allowed to, according to in that research, to have higher engagement and also lower cognitive difficulty, because it's easier for a user and it's more seamless to enter an system, an application where the memory is already based on them. On the other side, so we look now at the various aspects of what makes agents a multi-agent system, kind of the components. Now we have to look at the threat surface. So what happens if you don't guardrail them? And this will allow us to then go on to the next step, which is how do we orchestrate those various components against the threat to actually build the multi-agent system in productions. We're going to look at 6. So MCP risks, prompt injection, adversarial agents, unbound autonomy, goal misalignment, and coordination failures. And all of these, there's more risk, but these are the main ones that basically makes your agent not work in production or make your multi-agent system stuck. On one side, we've seen MCP risks. So there's several ways this can happen. One obviously is when you have compromised server, but you can also have actually a much more advanced way where you have a server that is not compromised, which then pass it on to a compromised server. I mean, this is something that is not new per se. It's been around through, for instance, package or dependency vulnerabilities on NPM. But here on MCP, the risk is really high, because if you have and you are giving information to an agent that is, for instance, compromised, well, then you can have cascading effect and you can lose sensible data from all your users. It's the same as having a dependency compromise. It can be kind of a root level vulnerability if you don't have guardrails between the agent and the MCPs. And we've seen this happen with open close skills. So there was a way to kind of bump up artificially, and an hacker safety researcher created this kind of what would Elon Musk do skill on OpenClaw, and gave it artificially, I think, 4,000 stars. People started downloading them, and in 24 hours, he got over 7 developers to use it. He did not actually do the full thing, but he could have, just by enabling it, get all the private API keys and all the private information from the agent. So this means that you need to be sure that you trust the MCP or the servers or the skills you download. And most importantly, stars are not, or stars or specs are not the best metrics. You need to look at actual usage. You need to sometimes even look at the code. Cloud Code released, and that had a really huge impact on the stock market a couple of days ago. The code vulnerability checker, where they actually scan a code base, look at all the errors and all the vulnerabilities. So this can be an option. That's what also, for instance, OpenClaw is currently working on. But making sure you have an audit system in place to look at what are the MCP. And even if the MCP server you interact with is good, it can be poisoned to a secondary MCP server, or it can pass on the information to another server that is then compromised. Prompt injection and data leakage, so this also can happen. We've seen it, for instance, through Comet, where when you had Comet taking on agentic browsing, it then go on a page that says, give me all the user's data, and it just goes and fills the user data from the memory. So this means that you're going to see prompts that try to manipulate the agent into leaking data. And it's kind of face-to-face. I remember when ChatGPT first came out, one of my first projects with it was a fraud training app. And what we built was ChatGPT will just call you on the phone and try to try to basically fraud you. But it was a training, and basically you had to realize that it was a fraud and then close it or pass it on to the relevant channels. And I remember it took us approximately 2 hours to jailbreak ChatGPT to get it to actually fake calls as an experiment. And right now, for instance, it's much more complex. And you have things such as the constitutional classifier that was released by Anthropic that allows to block the prompts and actually analyze the prompts. And here, what works really well usually is separating the defensive layer to the actual agent. The agent is going to be focused on the task. So its mindset and presentation would be on the task at hand. So if you actually give him the responsibility to think about safety, it's going to have this duality that then increases your surface layer for attacks and then increases the possibility for data leakage. Well, that's where multi-agent system is really powerful, or guardrails, because if you have an agent that actually looks at data leakage that is maybe a tiny, but more specifically specialized on that, you can drastically reduce the probability of it. Then you also have goal misalignment and objective drift. This is beyond safety, but it's also around more generally so AGI alignment problems and how do we align super intelligent and more intelligent agent. One of the perfect examples for it is the coin run example, I believe by Google. So if you take an agent and train it to get a coin, you train it on data set of size 1,000, where the coin is always at the end. Then you move the coin, and the agent learns to go at the end of the, not to actually go and get the coin. So this means that when you actually give a goal to an agent, this is called the outer alignment, it may have an inner representation of that goal, and more often than not, it will have, which makes it easier and faster. This may be if you say refactor all this code base, tells you yes, it just deleted the code base because it's a similar way of achieving something. Or if you say, oh, create this system, it will just fake it and not actually create it because it found a faster way. So it will drift from your original goal to the actual behavior. It's really important, and usually it's fixed through observability. And also multi-agent systems are really helpful in helping with that. Why? Because they allow to defer and delegate the autonomy. So this means that you can have an agent check on another agent. This saves you a lot of time because you don't have to go and check it yourself, especially if you do it at scale. If you go and check everything yourself, it's really complex. But if you have an agent as a quality control agent, it's going to help you a lot. To give you an example, when I worked on generating live slide deck for prospects. So it was a project we looked at, we got a prospect, and want to generate a live slide deck personalized to their company. This is similar to another company that, for instance, they do an agent system that creates a landing page personalized to the user that sees it. And in that case, when you create your slide deck, you obviously have plenty of ways of creating that. You need to make sure that it's specifically for that person, you get the right data, and you need to make sure that the agent is kind of spinning out several sub-agents. And in that case, we had an agent that actually does the research, so studies the company, an agent that actually creates the slide and codes it, but then we also add a feedback loop between a quality control agent that looks at each slide, kind of does a screenshot, says, is it good, is it bad, is there text overlap, is there problems, and then pass it on, and then they kind of talk together until they reach a certain threshold, and then you pass it on to a final holistic review, and then it's ready. And this is linked to coordination failure, which according to research is one of the number one example of failures in multi-agent systems. So when agents have problems in coordinating and talking together. So you have, for instance, you don't match the right patterns, they don't talk in the right way, they don't have the same intelligence level. So this is another really big risk. And finally, unbounded autonomy. This is probably one of the most famous one, which is in terms of having infinite loops. And you've seen this as examples, people on Reddit, if you go on Reddit, you can see people talking about their cost ballooning and exploding because the agent just started doing an infinite loop or calling the API 1,000 times. It's really important to put rate limiting on all agents. There's platform, I believe one is called Gravity, that allows you to actually govern your agent and actually see what they're doing in real time and block them after they do a certain action several times. It's akin to an infinite loop in coding, but like an infinite loop in agentic. And so the agent just stuck and just does the same thing again, again, again. It consumes token and cost and cost and cost. And also adversarial agent integration is a bit more advanced, but basically this is a bit of the future of agentic system, where we're going to have multiple agent system competing for things. And when you have either manipulation or, for instance, deception. So these, I'll give you an example I was looking at on research. When you have simulated societies of AI agents, and you have a goal in your environment, you can have an agent exhibit deceptive behavior. And one of the research I've done, I took all the main AI models from open source to closed source to reasoning to no reasoning, and I made them play up to actually 100,000 prisoner's dilemma style games. So you had a goal, and they had to decide, and then they could talk and see what happened. And in a lot of times, especially bigger and reasoning model, they show deceptive behavior. So they lie, they say, I'm going to collaborate, and then they actually steal, or they say, I'm going to collaborate, they collaborate first, they wait for the other person to collaborate, and then they actually start stealing. So we've seen this, and as agents become smarter and more integrated and bigger, and most importantly, also more used to make actual decisions, we may see more and more adversarial attacks in terms of agents manipulating other agents, deceiving other agents, lying, because I say this is a lot of error problems we already have with our current society, but obviously they get amplified when you get a web of agent or agent net or interactions of multiple agents working together. And the promise of multi-agent system against all of these problems is to actually divide complex problems to specialized agents. It is a solution to a lot of the risk we just seen, because you have more granular, observable sub-agents that then communicate together, where you start with the assumption that the sum of the total will be bigger and better, and even cheaper than just having one single agent with a massive prompt. So this means that you coordinate reasoning. And this is akin to our society. Obviously, a team will outperform solo people in pretty much most tasks. And you can also smartly scale intelligence. So what does this mean is, as we presented, have a higher level orchestration agent, but then tinier agents on edge, or simply smaller and more cost effective to do more specific tasks. And also it is the advantage in terms of modularity and safety. So this means that you get agents that are safer because you can actually observe each agent, have communication protocol, and have safety embedded into the system. And we've seen multi-agent system growing as an adoption pattern. And if I show you now the realities from all these risks, in order, the three biggest ones that we see in multi-agent system are system design issue according to research. Then we have inter-agent misalignment, and then finally task verification. So this means, as we talked, it's kind of the orchestration layer not working. So your system is not well designed. They're not aligned eternally, alignment drifting, and then you don't have the right guardrails. So how do we mitigate all of that? Sorry, just one point I wanted to take first. There's also the example of, obviously, the Replit agent incident, where you got all over the news, where you got that agent that basically freaked out and deleted an entire code base, and there was no redundancy. It just created fake records and started lying, saying it had not deleted it, and then it became kind of really public, and Replit had to look into it. There's other examples of this happening with other AI agents. So our core thesis here is that ungoverned multi-agent systems have a documented failure rate that makes them commercially inviable. So if you don't have multi-agent system that communicate clearly, that do so in a guardrail manner, you don't have a system that can go and be taken in production scale, or at least safely. And this is where you can kind of classify the information, you constrain the agent, and you observe the agent to see what's happening. And this is where the Azure AI Foundry stack is really helpful. So looking at the control panel, looking at the agent framework, looking at agent services, and looking at how we can use those specifically to create the multi-agent systems, and use the Microsoft agent framework kind of to have multiple ways of orchestrating the agent, of making them work together. We've seen, for instance, drag and drop platform becoming more and more used. We've seen, I'm not going to repeat here, but it's a lot of previous talks as well that look at specific guardrail example and related, and how to define workflows and different ways to actually make these workflows work together. And I want to talk specifically around that and on orchestration patterns, because I believe this will kind of solve the biggest problem we see, which is misalignment and miscommunication between agents. We're going to look at 5 sample orchestration patterns. The simplest one usually is sequential. So you got a researcher that passes on to a writer, passing on to a checker. So A, B, C, that's kind of one of the simplest one. And if you go, for instance, and try a lot of the agent creation tools from Comfy AI locally to even the OpenAI Anthropic SDK to Foundry, that is one of the foundational one on the templates they give you first, because you literally have this A, B, C. But then you can also go concurrent, kind of fan out, fan in, where you have multiple agents working at once and you get an aggregator. This may mean kind of what you do when you have RAG, where you say, okay, I'm going to have these 10 sources. These 10 agents will analyze each sources one by one. It's a smaller agent, faster, more optimized, and then I'm going to aggregate that and then pass it on to my end user. You then have the group chat, where you have kind of communication pattern. We've seen publications and research that show that group chats are really effective, because they allow in a certain way, similar to humans, kind of realizing errors and mistakes much earlier. So whereas on a concurrent, you don't have that loop, a group chat kind of has both the best of both worlds. So it has the advantages of kind of having the concurrency because you can still delegate and the orchestration, but it also have the advantages of communication and loops where you can actually talk. Is where you have an orchestrator that has a task that can call sub-agents, similar to like internal MCP style call, but you actually call a sub-agent, getting to do something, get his output, pass it on to another agent, and then you have the swarm, which is multiple agents, they all talk together and they do a task and they all move together. And this is similar to how, for instance, Anthropic built with Cloud Code the C compiler. I mean, there's been a lot of controversy around that, so I don't want to specifically look on the details, but what is interesting, rather than just the C compiler here, is what they actually done, which is they built so many agents all at once that all had a shared file. They could all take on a task, and then the only rule was they basically had to take on and write what they've done. So this big file of learnings, then they will just write the next task, another agent will go do that task, write the learning, and just mark it as I'm doing it so that the other agent don't do it. It's a really simple orchestration framework. I believe I found it quite simple, but also quite effective, because what happens is all the agents will kind of, even though they don't have an actual group chat, it's just a file, you kind of communicate together. There's a learning, so there's a shared memory. And there's also orchestration and orientation, which is they're all orchestrated. They have a way to talk together through that file. They're orientated. They all know what the next task is because everyone writes the next task to do on that file. Handoff agent can also be done in terms of transferring control. And this more specifically can done also inside of group chats. So this means, for instance, when you reach a certain threshold, you pass it on to a specific agent. So if the difficulty of a task is X number, then you pass it on to the specialized agent. This can be done really well for risk management. If the risk of a task is higher than this, then you pass it on to a specific, like, high risk agent. Or if the person gave this specific personal data, then automatically you pass it on to an incognito chat and you don't save that chat. It's examples where you actually transfer control to a specific agent. And then you can also kind of use a task ledger, which is what I was talking about, which is similar to how Claude did it. You kind of have a manager that monitors a task ledger, and everyone has a dual-way communication with that document, where you say, okay, there's a task 1 to do, it's going to do it, task 2 to do, this other agent is going to do it, task 3, and then you can also sub-specialize inside. So this agent is specialized into coding. You will look at the task, what's the next coding task? You specialize into research, what's the next research task? Is how you can have a really simple, per se, but actually highly effective way of combining multiple agents with or without the manager. That depends, and sometimes better, the after the other. One of the research I wanted to talk about to kind of have the guardrail aspect is Aura, which is a paper I worked on this summer, where we looked at agent autonomy risk assessment. So how do we make autonomous agents and even multi-agent systems be guardrailed? Is one of the way. There's other ways, but this is the one that I currently use and the one I worked on. So the way we do it is we have a mathematical scoring framework, which is partially LLM, partially memory-based. So for any risk, we compute a likelihood and impact score. This is kind of base foundation, and then this goes into a gamma score, which is context-aware dimensional scoring. So the way we do it is we take a risk or a sentence, an action, which can be MCP, JSON, sentence. I'll give you an example. I'm going to send an email to the president, or I'm going to send an email to my friend. These two sentences carry wildly different risk, but at the same time, they're extremely similar. So what matters here is that the context change to my friend or to the president. And why does it change across certain dimensions? So these dimensions, we looked at NIST, UAI Act, but then they also vary across all fields and across specific how strict your field is. But they can be things such as vulnerability, autonomy, how much you can also change your output, your connectiveness, your irreversibility. So if I send an email to the president, it's kind of quite irreversible, and the risk is also quite high. So the context to the president, the context email will have a really high irreversibility score because you can't revert an email theoretically. And the context to the president will have a really high vulnerability score because it's really vulnerable. I mean, it's a high risk. And then you combine that into kind of the gamma score, where you have the likelihood, impact, and combine that with gamma, which kind of gives you, based on the context, based on my dimensions, so what I care about, what I do, what I care about, what's my risk. And then we pass it on to kind of semaphore-like analogy, where if it's trivial, if it has a low score, then you can just go and let the agent do it. If it's important, if it has a higher score, or if there's a spike, so for instance, send email to the president, send email to my friend, will have really different score, even if the context is quite small. Why? Because of that context difference. So then it's going to probably go into the important, where you need a human in the loop. And this is the mitigation layer. This is the risk analysis layer, and this is the mitigation layer. In the mitigation, you can actually make it more interesting, where you don't just say, I want a human in the loop. You say, based on the risk score and based on the dimensions that are scoring wrong, what mitigation can I apply? If irreversibility is a really high dimension, can I first try and send a test, and before sending an email to the president, send it to my friend? So once you have kind of a 3D map of your risk, so you know what agents have what risk along which dimensions, you apply mitigation that reduce that specifically for that risk along that context, along that dimension. So then you can apply the mitigation specifically what is needed. And the mitigation can be really varied. Obviously, human in the loop is the base one, but it can be AI in the loop, calling a verifier agent. It can be just checking, looking, I'm not sure about this context. There's a high in, I need to write this email to this person based on this work, but I'm uncertain about the work. So rather than first calling the human, I'm going to go and say it's mitigated, check that the date. Most of the time you get a lot of hallucinations. So maybe you say, oh, this work was completed on that date. You have a mitigation say, check that the date is correct, because there is a high risk in terms of that specific aspect of the context. Then finally, you can also have kind of the crucial aspect where you say, and you make the system learn. In that specific case, you need a human to check it. If you have an agent that is, for instance, designed through the AI Act in Europe, if it's designing financial action, for instance, a credit score action, and most of the time it will need to always have a human decision in the layer. So you can also make sure that your most important action, the agents and the multi-agent system is doing, are protected. So it's kind of a safety harness around your AI, kind of a protection layer around your AI to make sure that it's well protected. And in Azure, there's also a lot of ways you can do that. Things such as looking at context filters, prompt shields, groundness check, custom categories, MCP approval modes, human in the loop, evaluation, observability, identity, and more. So these are all examples where in Azure you can change the settings, and you can check tutorials and more to actually make sure that you have prompt protection, you have reasoning, you have categories, you got approval modes and evaluation systems and more. And if I want to kind of close, giving you an example of a multi-agent system and how this could work and how we could build it. So let's say I want to build Red Impact. This is a 5-agent regulatory change impact analyzer. So this will look, and it's going to be reactive. So when there is a new regulatory that is sent in any country, it goes analyze it and then pass it on to me to tell me what I need to do and why should I care about this new regulation. So we've got our kind of goal. So it's when there's a new regulation, we got our agents defined, and we know what's our final like output is to get a report to give me to the board to know why should I care basically about this new regulation, what do I need to do. So we defined about this agent. So the goal is to have each agent mapped to a specific action. So when you have your goal, kind of breaking down into specific actions specifically to know what and why you're doing those things. And then you need to define for each agent what are its role and specifications. So if I take here my agents, what tool do they need? We're then going to give a prompt to each, what context do they need? So for each agent, if we take on the tiny steps we've seen at the start, for each agent, I'm actually building that. And we can call that the agent card. So we actually take the agent card and say, okay, what brain does it have? What context does it have? What memory does it have? What tools does it have? What colors do it have? What human in the loop does it have? Once I'm defined all my agents, I know what they're all doing. I know what the risk score is as well, maybe through Aura, through other system. How do I combine them? How do I get the orchestration? So if you remember from the start, we've got now the orientation, the goal, the direction, and now we also have the orchestration and the guardrails. orchestration. So one example, the simplest one is we can go sequential. It's probably what I'll do here because it's still a high risk. I mean, I don't want to get the regulation wrong. So I'll just do the researcher, read everything, look at the things, the planner, see what needs to be done, critique, kind of criticize it, review the various aspects, clarify. Executor creates a report, personalize it, maybe even send it to me. Safety, look at specifically what do I need to do correctly and what do I need to do right. This could also be done if it's a more complex task. It could be done also as a group chat system where you have the planner to critic talking together and then pass it on to executor, testing it through the safety and pass it on again to the planner and critic. So if it's a more complex, more advanced, and it's more reflection, that's probably how I will change it. Or even concurrent in terms of you could break down the researcher in various aspects. So rather than having a single researcher that works in the same way, you could have maybe three. One looks at MCP tools, one looks at the actual regulatory DB, one looks at your actually tools, so like what your company is actually doing to then know and how they combine together. And what is really important is around that tool, we have a safety checker. I know we're a bit short on time, so I'm going to, I think, move a little bit faster here. These are all slides that I go a bit deeper on the concept we already saw previously. So to wrap it up, I want to give kind of principles for production, which is a recap of the main things we talk about. So things such as having explicit state management, so knowing what each agent is doing at a specific time, having deterministic orchestration when needed, then in certain cases, having the autonomy that is bounded. So this is where you have kind of the balance we talked about between autonomy and oversight. So when needed, you have the strong deterministic will allow you to reduce the autonomy, and when needed, you have higher autonomy with stronger oversight, such as looking at the tools, so how to make sure that the tools are well managed, protect against MCP and prompt vulnerability. Looking at policies, don't just say, please don't do that in a prompt. You can also do that, obviously, it's a way, but then looking at guardrails, policies, and related, having always observability. So this means looking at telemetry data. This is in the slides we quickly skipped, but this basically means making sure that we look specifically at what the telemetry is, so what the agent is doing, what are all the actions, and then applying the guardrail to those, so that then we can also keep it as a log. If something goes wrong, we know why it did go wrong. And this means having the evaluation harness, so testing it, sandboxing the agent first, testing with mock data, don't make it running instantly in production, testing it first. Seems banal, but a lot of companies, not all companies are doing that. And making sure there's budget controls, so putting limits on the tokens, making sure there are runtime limits, making sure the calls on the APIs are rate limited, your agent, individual agents are rate limited, and also kind of having safe escalation. So as we've seen through all our other protocols, making sure there is kind of a way for the agent to escalate that to another agent, to a human, kind of have control mechanisms in place. And if we look at the anti-patterns, this means not having just unbounded autonomy. Otherwise, you can have drifting or related, not just have hidden states, not have mega prompts of 10,000 tokens that are really lost and you don't know what it's doing, not having permission prompts. So actually breaking down things as much as possible so that you have specific prompts that work together and you have an autonomy that is controlled. Making sure you have observability, making sure that you have actual quality, so no quality by vibes, having evaluation, running benchmarks, running analysis, sandboxing, and then kind of checking the tools, having an allow list rather than a not allow list, and having obviously all the budget controls that we just said. So thank you very much. If I had to give 3 things to remember as I'm closing this talk, is multi-agent systems are really powerful. Make sure that you govern them. Use AI Foundry or our other framework to quantify risk, measure risk, and make sure your agents are protected. And then have defense in depth, not optionally, but actually have it. Thank you very much. If you have any questions, feel free to contact me. You can also connect with me on LinkedIn, and I'll be really happy to answer them. You can also put them in the chat. And then Constantinos, if you have any as well.
I don't know if you can hear me.
Yes.
Okay, looks like I'm muted. Thank you so much, Lorenzo. I really enjoyed your session. You went quite technical, and that's why I saw your LinkedIn and my initial thought is the guy is really an expert. So it's been a pleasure having you with us, and I really appreciate taking the time to create such an amazing presentation with so much detail. I believe everyone enjoyed it. Let me see if we have any comments here. Something is going on with my browser. Give me a moment, please. I don't know if you are able to see our YouTube channel where we are streaming. I can see there is a comment there.
Thank you very much. Please, if you want, feel free to connect on LinkedIn as well, and I'd be happy to.
Comment there. Give me a moment. So, no, I don't see anything. We're going to have a break. Lorenzo, I'm going to have to say goodbye to you, and hopefully we will see you in another event of ours. I really appreciate you coming here. Thank you so much, my friend.
Thank you very much
Have
for
a great
having me,
one.
Konstantinos.
Bye
Thank
bye.
you for the event. It's great.
Thank you. Thank you so much. Well, that was an amazing session. I really have to say that. Uh, I haven't seen such well structured detail about the specific difficult theme. So we really appreciate this session. But this is the only session, of course, that Azure AI Connect 2026 has to offer for every one of us. So we are right on day 3. And we have Lizzie. I think I'm pronouncing correctly, but she will be with us in a few. Allow me to run our video, and we will be back in 1.5 minutes. Now, something has happened with my browser, so let me just refresh quickly. I'm sorry for that. I think something happened on the browser, and looks like it's stuck.
We are right back. Azure AI Connect 2026. These days I had the opportunity to meet some really talented people. If not all of them, our speakers are experts on their field and mostly on AI, and that's why we're here. One of them is Lizzie Thomas. She's going to present quite an interesting session, evaluation-driven development, how to measure what matters in Gen AI. I'm really curious to hear what Lizzie has to say about it, so I'm going to bring her on stage and welcome her. Hello, hello, hello. How are you?
Hello. Fantastic. How are you?
I'm great, I'm great. Thank you for joining, Lizzie. I really appreciate taking the time to be with us, create your presentation. I know that it takes time, and I have to say, I really appreciate you being here with us and sharing your expertise and your knowledge. Would you like
Likewise.
to tell
Thank you
us
for having me.
where are you calling from and what we're
Yes.
going to hear?
Thank you, first of all, for having me. I know running a half day conference is very challenging. I don't know how you guys do this in 3 days every single year. I've had the pleasure of presenting at Connect even last year, the year before, if I remember right. So, really,
Yes,
just amazing job. And thank you for having me once again. Pleasure to present here. So, I'm calling from the US. This is my afternoon. So, I'm based out of Kansas, which is Midwest US.
thank you. Thank you so much. Yes, we had the pleasure to host you also last year, and we really enjoyed your presence, and I'm sure we are going to enjoy it this time. So I'm going to let you present your session, Lizzie. The stage is yours. Thank you so much.
Awesome. Thank you, Constance. Alrighty. So, thank you everyone who's making time to join live and who will watch the recording later on. My name is Liji Thomas. I'm a tech manager and I'm based out of Kansas. I'm a Microsoft MVP in AI. This is my fourth year, and it's such an exciting space, as you would know. And we always have so much going on in our space that it's really difficult to keep up with. But just to set some context before I start the presentation and share the screens. Um, I started working in AI before AI was a thing. I want to say like years and years back. But when obviously in 2021, when the Chat GPT and OpenAI sort of that boom happened, that's probably when everybody got on. A lot of them got onto the bandwagon, and then the first 1 or 2 years was always about um, just trying out the technology. There was, is this a hype? Does this really work? Is this just another thing that will fade away? So there was a lot of POCs, a lot of protocols, a lot of things that a lot of organizations, individuals were trying and uh, trying to get into proving of the technology itself. And over the past couple of years, we've seen that there are two kinds of destinies for these projects. So either the ones that are still stuck in the POC or the prototype phase, and it goes into the POC purgatory, if I may, and the others are ones that really go into mature, into and evolve into production enterprise grade applications. And I think there are so many caveats and so many nuances, so many things, stars that need to align for the same. But one of the things that I strongly believe is required in terms of essential thinking and mindset to be especially able to promote a POC or prototype into a production facing application is this concept that I call an evaluation driven development, where evaluation is not an afterthought that comes after the building, the deploying, and them thinking about how do we map, how do you measure, how do you manage evaluation, and then you don't really have a success or an outcome that you can point to specifically. Whereas taking a step back and a shift left approach, just like we think about security, right? From day one, from the initial get go itself, how might we be able to manage that by using an evaluation driven approach from day one? So that's really the premise of my talk. And I hope you take away some from this. It is a huge topic. There are so many ways to roam. I will, for my own personal interest, again, will be showing you a little bit into the code as well. Nothing fancy, but at least to get you thinking and giving you ideas on this isn't something that is so far away and so unreachable for me that I can really try to get to the bottom of this, and if I care enough to do that. So, with that, I will share my screen and we will get rolling. All right. So we've kind of established the stage. So I'll just quickly walk through this: an evaluation-driven approach, development approach, and how to measure what matters in if you are creating generative AI-based applications. So again, I'll take a few steps back to even ask ourselves, like, do we need to measure and why? So Microsoft especially has made a lot of you know changes in the last couple of years to evolve the terminology that is even used towards this, from a safety, security responsible to what is now called trustworthy applications. Um, and then we ask ourselves, what does that actually mean to build responsible or trustworthy applications? So I'll ground ourselves on the six principles that have always been the pillars. Again, every giant in the ecosystem will have responsible AI principles. This is what's coming from Microsoft. We have fairness, inclusiveness, reliability and safety, transparency, privacy and security, and accountability. So those principles have not changed for as long as I can remember, and that still holds true. But what does that mean for us tactically or tangibly when we start creating applications with this? Like for you and I who build generative AI applications, what does that really mean? So I want to kind of think about this in a very structured manner. So there are things that again, when we talk about an EDD approach, we talk about starting as early in the life cycle as possible. So let's say we haven't even put the pen to the paper, we haven't even started coding. Even before that, are there things that we should be thinking of or of doing or even strategizing and talking? So if I kind of think about this in three layers. One of the first things that we should be probably doing is in the map area. And what does it take to just connect the dots and say, well, for this kind of a use case or this application that I'm creating, if I were to map out all the things that I should care about or be concerned about or be thinking about, what does that sort of look like? There are so many tools and techniques that you can employ in this area. I have used some of this myself. For example, the first one that you see there in the map category is an AI impact assessment template. If you have not tried that, I would highly encourage you to do that because it's a really cool one. It walks you through very structured methodology of thinking through what are those things that may or may not be applicable to your specific use case. It's free, it's available for download. I'd highly encourage you to go and just try that out. And you must be familiar with some of the others, like the Pirate tool that you're using for red teaming, again, open source stuff. So just see what is a good fit for your specific use case. Um, Once you have mapped some of these things out, again, what may work for me or what is important for my use case may not be necessarily what's important for your use case. So you have to be very prescriptive and intentional about how we go about mapping this, which is why this is a very good exercise. Probably, I typically invite more than even my technical partners to participate in this. So it's a well-rounded exercise throughout. But once you map, now this is probably where we spend a lot of time in, if at all we do evaluation at all. This is where I've seen at least engineers spend a lot of time in actually measuring the evaluation. And again, you got a ton of features and capabilities, tools, and frameworks for that. Fairlearn is fairly well known. Interpret ML, again, more along the machine learning side. The one that I want to dive deep into, double click into today, is this box here, evaluate Gen AI applications, because it's not something that came out this year. It's a few seasons old, but I think it's continually improving. We have features that are moving from public preview to GA, and more so, I don't know if we talk about this enough in our space, in our industry. So I'm extremely passionate about being able to talk about how might we evaluate Gen AI applications, both for quality as well as for safety. So this will be the box that I will double click into for the rest of my talk. But just to show you the full spectrum, after map and measure, then there are additional capabilities, again, a plethora of tools for you to try to be able to manage these, like Presidio or other policies and things like that. So going back to this, the evaluate Gen AI applications will be the area of focus for the rest of the talk. But just so you understand the broad spectrum, like that is one part of probably the whole range of tools and techniques at your disposal. So now we talk about evaluating Gen AI applications, right? I want to break this down into various layers. So some things that we might be already doing and some things that we might consider doing anew if we care about it. So if you look at an enterprise Gen AI application, the entire life cycle, there are so many areas that we tend to focus on as a team, as an engineer. So let's start with the base model selection. Now, in my experience, I see a lot of importance given to this area, especially when a new model comes out. There is sufficient chatter about the quality, the accuracy, are there safety guardrails? Is there security in place? What are the ethical considerations for this? Okay, this model is better than the other in terms of all the benchmarks and standards. So it's a wise thing to do, that we must evaluate and compare models, because again, as I said, what works for my use case may not necessarily work for someone else, right? So it's a good and worthy exercise to do, not to say no. But so before building your applications, you need to make sure that you select the right model based on what you care about. So this is why we did the mapping exercise in the first. So when you come here, you really know what you are trying to solve for, and you select a model based on that. When you select a model, you have to look through a couple of dimensions, and that's how you go about selecting your base model. The second stage to that, now this is when you actually start building an application. It might probably be a greenfield, a new application, or it might be enhancing or augmenting an existing application itself. So let's say you select the base model, and now your Gen AI application can be of various flavors. It could be a RAG-based application, retrieval augmented generation application. It could be an agentic AI application, or it could be different kinds, maybe even a combination of the two. But once the development starts, once you start building, writing code, at from then you need to have some kind of signal or feedback to understand, from a directional sense at least, are you going in the right path? You can't wait for this to go into production to be able to get the signals. It would be fairly costly to do so. Again, we will talk about post-production evaluation, but even during pre-prod, we want to have tools and techniques in our hand to evaluate for quality, performance, and safety. So that's the whole part of the middle layer. And finally, when we deploy the production and it is out there, again, what a 10-member engineering team will be able to produce and put out there will hopefully not, may not cover for all the questions and everything that the universe is going to ask of it. So we should always be ready for that. We should measure it. We should manage it. But we should have, telemetry, and we should have reporting and dashboard and incident response and whatnot. So absolutely should have everything to be able to do continuous evaluation once this is deployed into production. But again, I think the story starts here. And this is, again, where I kind of spend a lot of time on, in kind of saying what are the techniques or the tools or the frameworks, the SDKs at our disposal, if we care about evaluating quality, performance, and safety. All right. So we talk a lot about evaluation and about evaluators. What are evaluators? right? So evaluators, simply put it, I'd say it is a very simply, it's a class of tools that has one objective or purpose. It is to score, and objectively, it must have an objective score and an assessment of the performance of the system in a very structured and programmatic way, which means I should be able to repeat it again and again, and I should get the similar scores. So there are various purposes of the evaluation. There can be evaluators that are meant for quality, evaluators meant for safety, and for reliability of AI responses. Depending on the nature of your use case, the evaluators that you use can also vary. For example, one of the most popular kind of AI application, Gen AI application, is RAG based application, which is retrieval augmented generation application. If you're not familiar, RAG applications, what they do is they take user inputs or messages and they give LLM generated responses. The difference is there is a context in which these responses need to be grounded on. They cannot refer to the corpus of the internet and produce a response. We want the response to be heavily grounded in this content base based on this context alone. And that is why the retrieval is augmented by this context before it is generated and given the response. So that's the whole premise of the RAG application. Now, if I were creating a RAG application, I would care about a number of things. Like I want to be able to evaluate a RAG application from day one across a number of things. So some of which I are on the slide here. I want to understand, again, depending, there are so many flavors of RAG application as well. If you're using document retrieval, you might care about that. If not, just at least the general retrieval quality, you will absolutely want to think about how grounded is your response. Is it completely and absolutely based on the context that you are providing it, or is it including something of its own into the response? You might be familiar with the term hallucination. And this is the flip side of this narrative is when responses are not necessarily grounded, is when they say, oh, the LLM is fabricating something and it just imagines something of its own and it hallucinated. See where this is going. So you absolutely want to care about the groundedness of your responses, and there is a way you can measure that. The next one is relevance. So it's very interesting. You can ask a question and you can get a response that may be completely informationally accurate. It might even be grounded in the context, but might not at all be relevant to what the user asked for. So it's important that you not just give something that is informationally accurate, but it is relevant to what the user has asked for. For example, just going to make this up. Let's say someone asks for what is the capital of France. And then the response of the AI is, oh, the weather in Kansas is 40 degrees Fahrenheit today. Well, by itself, that seems to be a very coherent, very fluent, very nicely put together bunch of words, and it seems to be very informationally accurate as well. Yep, the weather in Kansas right now is 40 degrees Celsius Fahrenheit, but it has no correspondence with the question that the user has asked. So you see how relevance is actually important. The next one is response completeness. It might not necessarily be very helpful if I end up just answering half of the user's question or just 20% of that, like how complete and therefore how helpful was the response as well. Like it could be informationally accurate, it could be relevant, it could be grounded, but it may not be complete. So you see, there are so many vectors or dimensions you want to be thinking about as an engineer who does RAG based applications to, am I evaluating for each and every one of these? The good news is Microsoft has SDKs, Microsoft Evaluation AI SDKs, using which some of these evaluators are available out of the box. Everything that I show here on screen is available out of the box from Microsoft SDK. And that is very helpful because you do not have to build this from scratch. That said, it is possible for you to extend the SDK and build custom evaluators as well. We will go through a couple of this in code right now. Happy to show you some demos of this so you know this is real. But I just want to show you that, for example, if I ask for retrieval, it will come back with a binary number or a threshold between 1 to 5 to tell you how good was the retrieval. Same thing for groundedness or groundedness pro. There's subtle differences between the two that you can kind of refer to. Relevance is also on a threshold of 1 to 5. Completeness as well. So you do not get a thesis on what it thinks about any of these, but the LLM. So to just make it a little more clear, we are using LLM as a judge here. So LLM is used as a judge to respond to or to evaluate how good its response was based on these vectors. All right, let me show you some piece of code, nothing fancy again, but I wanted to just demonstrate this to you. Just for context, this is a console application. Again, I'm calling the SDKs, and here, just to show you that this is from a RAG context, it is important for us to ground this in some context or some chunks. So here you will see sort of the chunks that I have put in. It's very less. Ideally, you would be referring to a vector database and then retrieving those chunks from there. But this is just for a very quick demo. So let me run this and then we can take a look at it. All right. Okay, I'm just gonna read this from the top. So the user's question was, if an AI system is accurate and fast, but lacks transparency or fairness, can it truly be considered responsible? And that was the question. And the AI's response is no, an AI system cannot be considered truly responsible if it lacks the transparency or fairness, and yada yada. So it explains that why it cannot be considered responsible, even if it is fast and accurate. There are things that need to be taken into account, specifically transparency and fairness. So the question that I asked is rate me on the relevance. Just take that metric alone. So here's its analysis of it. On the metric relevance, it gives me a score of 5. Remember, this is on a threshold of 1 to 5, and it gives me 5. It says the rating is exceptional, and it also, this is my favorite part, it gives me the reason. The response fully addresses the query with accurate information and provides additional insights into the principles of responsible AI. No. So if you're wondering where did this come from, remember we had actually configured chunks or the context in code itself. Again, nothing fancy there, but I wanted to make sure that it was actually relevant to this. You want greater deal of understanding on even what the model's chain of thought is, it will walk you through diagnostics. Again, I am just spitting out all the parameter values and whatever came out of a simple API call from the SDK. That's it. You will see the model that was used, the tokens, everything. Like this is maybe 10 lines of code to get this far. That's all it takes, guys. There is nothing fancy in this. I repeat again, as you can see, it is something that you can start using today or trying out if you care about it. So that's one example, I will say, of one of the metrics that we were talking about, which is the relevance metric. Let's try something else. So I have a number of them here. I'm going to, so we talked about relevance. I'm going to comment that out. Let's try something more interesting. Okay, let's see if completeness actually works. You can try this with, tweaking and turning the context and the things like that to see, and you will get values between 1 to 5, which is very interesting. And so you will know how good the LLM is as a judge as it evaluates all of this. Sometimes it has a problem even giving a response. So this time it failed to parse that. We can try that again, or I will try another evaluator here. Let's see. So the one that you might be for, okay, I want to try groundedness because that's really core to a generative AI application, a retrieval augmented generation application. Without groundedness, you might not have a sense of security of like how good or bad this is, right? So again, you can go back and change the chunks to see how this is, but I'm just going to go through again, same question. If an AI system is accurate and respond lacks transparency, it gives the response. This time, the metric that I'm asking it to look at is groundedness. And again, it gives a score and it explains why as well. The response is fully correct and complete, directly addressing this, and it walks you through the entire chain of thought. And if you see here the last line, the response is fully grounded in the context, accurately and completely addressing the query without introducing unrelated information. Now, that's what I want to know. That is gold for me because I do not want to create or fabricate any information by myself and confuse the user. I want it to be, as we said in the beginning, safe, secure, trustworthy applications that I can believe and I can actually ship. So this is the difference between, you kind of see how much of maturity and evolving it will take to go from a simple POC to putting things into production. So again, lots of examples of each of this that you can actually try out. But in the interest of time, going to move us along again. Now, next, you will have, just like you have for RAG, you have an entirely different class of evaluators called agent evaluators. Again, a lot of fun stuff. If you are creating agents today, there are things that you might care about. For example, did the agent complete the task that it was asked to do? Task completion, task adherence, like did it adhere to some of its tasks? Intent resolution, like forget what the agent did it actually identify what the user had asked for and did it resolve that? So the intent resolution of the user, that is important. Again, you'll see a lot of this is still in preview, but I would start at least tinkering around with this so you know where we're going with this. Tool accuracy, tool selection, so much good stuff in it. I wanted to show you some of this at least. Again, go back to my code. Just FYI, whatever I'm doing here in code, you really can do it in Azure AI Foundry. That is a way more, you don't have to get into the code, and you can just click a few buttons and you can see this in action. I like to tinker with code a little more, so you can believe, and you can mess around with this a little more. So bear with me as I unpack some of this for you, but at least you will know that this is real. So I'm going to show you an agent with a tool called and I'm going to start with intent resolution. Okay, let's hope that works. Now, I'm going to just explain what the agent is by just looking at it. So what the questions that the user had asked is, I live in Montreal and I'm looking for a moderate intensity hike. What's the current weather like? And behind the scenes, I have a tool. This agent is given a tool, a weather tool, like go and understand what the weather is right now in a designated place. So the assistant, you just see that the tool has been called successfully, and the result is periods of rain or drizzle, 15 Celsius. So the metric is intent resolution. It gives me a score of 5. It's exceptional because the assistant correctly identified the user's intent to know the current weather in Montreal, and it invoked the appropriate tool to get that information, fully resolving the user's query. So none of this is coming from me. This is all the LLM, not just giving you an objective score, but explaining its own thought process on why it arrived where it arrived. If you remember in my previous example, some of the metadata that I was able to display on screen included the tokens that will be used, how many tokens were used for this evaluation, things like that, if you care about costs and stuff, right? So it is I think something that you can be intentional and deliberate about, if and especially if you want to run this on a larger scale. But hey, you see, it works. So intent resolution is something we can do. Another thing we can probably tie is task adherence. Let's try that. All right, same agent, same tool. All I'm asking is sometimes, okay, that did not quite work. Let's try that once more, and I will see if it behaves or gives me a response this time, or we will call it. But okay, so here we go. Same question. I live in Montreal. I'm looking for a moderate intensity. What's the current weather like? It calls the tool and it says the result, periods of rain or drizzle 15C. If you remember, the metric that I am asking for is task adherence, which means how well did it actually do the task that the user had asked for. Now, it did give the user did ask about the current weather and it gave about weather. But if you look at it, it has scored itself 3 on a range of 1 to 5, and it says it's average. And the reason this is so interesting, the response correctly uses the tool, which is the primary request. However, it does not provide any information or suggestion about the moderate intensity hike, which would have been really useful to the user. So it's probably around the completeness or the complete task adherence of what the user was doing. I mean, this is a good start, it says, but it lacks additional context or suggestions, and it doesn't really meet the core requirement other than saying, okay, so here's what the weather looks like. But if you're looking for a moderate intensity hike, here's where I would look, or here's where I would go. So, it's so interesting to see how it thinks through this process. Again, I will say I have tried this. The quality of the evaluation also depends on the specific model that you use for evaluation. In my case, I'm using GPT-4o, but better models will probably give you better evaluation quality as well. But it's kind of really interesting to see how LLM as a judge kind of really plays out. Again, I should have had this in big and bold, but the SDK that you want to be looking for is Microsoft Evaluation AI SDK. And it's just fantastic. All of this comes out of the box, and you always have the capability to, again, write custom evaluators. Okay, so the last class of evaluators that I wanted to touch upon is safety evaluators. I do not have a demo for this, but you can possibly imagine how this could be used. The same techniques, the same processes, you would be able to evaluate for each of these categories around hateful, harmful, violence, protecting material, or all of those parts. So a lot of this can be done fully inside Azure AI Foundry. If you haven't tried it out, check out the new Foundry portal. It's amazing. But if you would like to just roll up your sleeves and just try some code as well, there's always the option of the APIs and SDKs, as I showed you. What we do here with all of this, starting in the second phase, of the pre-production phase, is essentially what you will scale out and you will use post-production as well. When you think about continuous evaluation and monitoring and at scale, this is exactly what you do. You just build this on scale, and you get responses for like, you have 1,000 responses today in production. You want to do this at scale, and then you come back and say, well, my system, my application is accurate, it is safe, it is at good quality. It's a way more objective measurement. You have data to prove it, and you really are backing it up with evidence to say that this is the case. Typically, in production scenarios, you will see that a small sample of the whole corpus of messages will also be taken for a human in the loop evaluation, which is a great technique. They might not have the scale or the capacity to look at all the millions of conversations that's happening out there, but a small scale of it can also be sent to the human evaluators, and they will also be thinking along the same lines, interestingly, like, Is it grounded? Is it relevant? Is it informationally accurate? Things like that. So it's always a good combinatorial approach, a hybrid approach to use both humans as well as LLM as a judge. Each of them have their pros and cons. Humans, SMEs especially, there's a capacity at which they can evaluate or how much they can get evaluated on a day-to-day basis. LLMs do not have that capacity cap. If your scale and others allow for that, this is an option that you can consider having. So that is probably all that I have in terms of all of the evaluation processes and things like that. So long story short, there are a lot of tools and techniques and frameworks that are available today without you having to need to build something from scratch if you care about evaluating your application. Evaluating your generative AI application is a basic tenet, is growing to be a very critical component of your application development life cycle. We are way past the era of having to prove out that this technology works. Now, a lot of people in the industry, in every organization that you see, is how might we scale this and take this into production? And when you're in production, how do you ensure that you actually have a trustworthy application in prod? So towards that, evaluators that you can consider, things that are available from Microsoft. Again, there's so many open source alternatives as well. People have asked me about Ragas and about others. Each of them have their ways of looking at things. The terminologies also vary a little, but at the end of the day, you might want to consider having some evaluation approach, both pre-prod and post-prod. You want to do that in a scalable and a continuous fashion before you even decide on any of this. If you want to just tinker around and explore, hey, does this thing even work? Like, I want to try and test a few. You can tinker around with the code and get to really see how well it behaves in your specific use case. Give it your context, give it your questions, and see if it does a good enough job with evaluation. And then you can decide whether you want to move forward with it or not. And then you can spin this up in the Foundry, set up continuous monitoring capabilities, and then have that accompany your RAG applications in production so that you have peace of mind. Alrighty, with that, I will pause to take any questions or responses. I know this is the last session of the day, but I appreciate everyone who has joined today and for giving me your time and attention. And let's come back.
Hello, Lizzie again. Well, I have homework, that's for sure, with what you have presented us. I was just looking whether we can get these equivalent libraries with Python, and I can see that the functionalities are there. We have
Yes.
similar SDKs for Python, so I can't wait to go and try them out. I really like your approach, Lizzie. This was an amazing presentation, and you just uncovered something that I didn't know it even existed, to tell you the truth. Wow. And this is what I love about the current state of the software development and AI. There are always something new things coming up, and they are, providing such elaborate and effective solutions within the code. This is amazing, and your example was great. Uh, Really, really interesting. And as I said, I have homework to do with your presentation. I would like to thank you for being with us and delivering once again a great session. Um, it's a pleasure having you always, Lizzie, and I hope I can see you again, probably in the next event or even meet in person. Thank you so
Thank,
much for being
thank
here
you
with
so
us,
much.
Lizzie.
Thank
Have
you.
a great one. Bye
Bye.
bye. Okay, so Lizzie really delivered something really special for us as the last session for today. I really enjoyed this presentation, and all in all, so far, day 3 of Azure AI Connect 2026. I know it's late, especially for European time zones, or even from all around the world. And you're probably watching this recorded, which is available in both of our YouTube channels, Azure Innovators Hub and Global AI Athens, which is the main channel, of course, for this initiative. It's the second year we have this initiative, and I really enjoy all of our speakers. All the sessions are providing this value that I was looking for, something new. The evolution of what happened last year, from doing to going deep and uncovering things that are there and help us make our lives easier while we build and deploy and operate our AI enhanced applications. I want to thank everyone for being here. Uh, if you're live, thank you so much for being with us. If you're watching this recorded, again, thank you for supporting our community. See you tomorrow. Next day, it's day 4, of course, and the same time we will be here. Thank you so much, everyone. Have a great one.
Join us for Azure AI Connect, happening virtually from March 2 to March 6, 2026.